Welcome to the calmest corner of the internet. Find a comfortable spot, maybe a cozy chair or a soft couch. Let your body relax, your mind unwind. This is a space where learning meets peace. As we begin, let the gentle rhythm of this tutorial start to wash over you. Close your eyes if you like, or just let your thoughts drift. Remember to like and subscribe for more relaxing coding tutorials. Let's begin. Welcome to this session on installing and setting up Perl. By the end of this presentation, you will understand the importance of properly installing Perl. Learn the key steps for installation and discover how to configure your environment effectively. We will cover the essential topics of installation procedures, environment setup, and verification techniques to ensure your Perl installation is ready for use. Before we begin, let's review the prerequisites for installing Perl. First, ensure your operating system is compatible. Perl runs on Windows, Mac OS, and Linux, but the installation steps vary across these platforms. Next, you will need administrative privileges to install software on your system. Finally, an internet connection is necessary to download Perl packages and dependencies from official sources. Let's start with installing Perl on Windows. The recommended method is to download Perl from the official website, such as Strawberry Perl, which is a popular choice for Windows users. Once downloaded, run the installer and follow the on-screen prompts to complete the setup. After installation, open the command prompt and type Perl -v to verify the installation. This command will display the Perl version, confirming it is correctly installed. For Mac OS users, the easiest way to install Perl is through Homebrew, a package manager for Mac OS. Open the terminal and enter the command brew install Perl. Alternatively, you can use Mac ports or download Perl directly from CPAN, the Comprehensive Perl Archive Network. After installation, check the version by typing Perl -v in the terminal. This ensures your Perl environment is functional. On Linux systems, Perl is often pre-installed, but you may need to install it explicitly. For Debian or Ubuntu-based distributions, use the command sudo apt install Perl. For Red Hat-based systems, the equivalent command is sudo yum install Perl. If you require a specific version, you can compile Perl from source by downloading the latest release from CPAN and following the build instructions. Once Perl is installed, configuring your environment is crucial. First, Ensure the path environment variable includes the directory where Perl executables are located. This allows you to run Perl commands from any location in the terminal. Additionally, set the Perl 5lib variable to include custom module paths, making it easier to manage third-party Perl modules. Finally, use the cpan or cpanum tools to install, update, or remove Perl modules efficiently. Now, let's verify your Perl installation. Start by checking the version with the command Perl -v. This will display the installed Perl version and build details. Next, create a simple script by typing print hello Perl and save it with a PL extension. Run the script using Perl followed by the file name to see the output. Lastly, confirm module installation by using cpan-d, which lists all installed modules and their versions. During installation, you may encounter common issues. If the path environment variable is not set correctly, Perl commands may not work as expected. Permission errors can occur if you lack administrative rights, so always run installers with elevated privileges. Conflicting Perl versions can arise if multiple installations exist on your system. To resolve this, ensure the correct Perl path is prioritized in the path variable. To recap, we have covered the installation steps for Windows, Mac OS, and Linux, emphasized the importance of environment configuration, and verified the installation process. In the next session, we will dive into writing and running Perl scripts, exploring syntax, variables, and basic programming constructs. This foundation will prepare you to harness Perl's capabilities for real-world applications. Welcome to Session 3 of our Perl programming training. Today, we will explore the foundational elements of Perl's syntax and structure. We will begin by examining variables, control structures, subroutines, and comments. These components form the backbone of any Perl program, and understanding their proper use is essential for writing efficient and maintainable code. Syntax in Perl is both flexible and powerful, but it requires careful attention to detail to avoid common pitfalls. Let us delve into each of these topics in turn. Perl's syntax is straightforward yet precise. Each line of code typically ends with a semicolon, which signals the end of a statement. This is important because Perl does not automatically recognize line breaks as statement terminators. Identifiers in Perl are case sensitive, meaning that a variable named var is distinct from var. This can lead to subtle errors if not handled carefully. To output text, we use the print function, as in print hello. Comments are denoted by a hash symbol and are invaluable for documenting code. For example, "This is a comment" provides clarity for anyone reading the script. These basics form the building blocks of any Perl program. Variables in Perl come in 3 primary types, each with its own prefix. Scalar variables, indicated by a $sign, hold single values such as numbers or strings. For example, name equals Perl stores a string. Array variables, prefixed with an @ symbol, store lists of values, like at numbers equals 1, 2, 3. Hash variables, denoted by a %sign, store key value pairs, as in %ages equals Alice equals 30. Understanding scalar context versus list context is crucial because Perl behaves differently depending on whether a value is expected to be a single item or a collection. This distinction affects how functions and operations are applied. Control structures in Perl allow us to manage the flow of execution. Conditional statements such as if, else if, and else enable decision-making. For instance, if x5 print greater, else print lesser, demonstrates how to branch logic based on a condition. Loops, including for each, while, and until, repeat blocks of code. A for loop might iterate over a range of numbers, while a for each loop processes each element in an array. Proper use of these structures ensures that programs can handle complex tasks efficiently. Let us examine an example to illustrate their application. Subroutines in Perl are defined using the sub keyword and allow us to encapsulate reusable code. For example, subgreet print hello world defines a function that can be called later. Arguments are passed through the array, and return values are typically the last evaluated expression. This makes subroutines a powerful tool for organizing code. By breaking programs into smaller, manageable functions, we improve readability and maintainability. Let us explore how to pass arguments and return values from subroutines. Comments are essential for making code understandable. Single-line comments begin with a hash symbol, while multi-line comments use equals begin comment and equals end comment. Proper indentation enhances readability, especially in nested structures. Including use strict and use warnings at the beginning of a script helps catch potential errors by enforcing good practices. These tools are vital for writing robust Perl programs. Always remember that well-documented code is easier to debug and collaborate on. In summary, we have covered the essentials of Perl syntax, including variables, control structures, subroutines, and comments. Mastering these concepts allows us to write structured and efficient code. Practice is key to becoming proficient, so take time to experiment with the examples provided. In our next session, we will explore advanced data structures and file handling, expanding on the foundation we have built today. Keep refining your skills, and happy coding. Variables in Perl are essential for storing and manipulating data during program execution. They act as containers that hold values, which can be referenced and modified throughout the code. Perl provides 3 primary variable types: scalars, arrays, and hashes. Scalars are used for single values, such as numbers, strings, or references. Arrays store ordered collections of scalar values, allowing you to work with multiple items at once. Hashes, also known as associative arrays, store key value pairs, making it easy to retrieve data using unique identifiers. One of Perl's most powerful features is its dynamic typing system, which means the type of a variable is determined automatically at runtime based on the context in which it is used. This flexibility allows for more concise and adaptable code. Scalar variables in Perl are denoted by the $sign symbol followed by a variable name. They are designed to hold a single value, whether it is a number, a string, or even a reference to another data structure. For example, name equals Alice stores a string, while age equals 30 stores a numeric value. Scalars are particularly useful when you need to work with individual pieces of data. It is important to note that scalar context refers to situations where a variable is expected to return a single value rather than a list. This distinction becomes critical when performing operations that require specific data types, such as arithmetic calculations or string manipulations. Understanding scalar context helps prevent unexpected behavior in your programs. Arrays in Perl are used to store ordered lists of scalar values, making them ideal for managing collections of data. The syntax for declaring an array involves the @ symbol followed by the array name. For instance, @numbers equals 1, 2, 3 creates an array containing 3 numeric values, while @names John, Jane stores a list of strings. Each element in an array is accessed using an index, which starts at 0. So number 0 retrieves the first element, which is 1 in this case. Arrays are highly versatile and can be modified dynamically by adding or removing elements. This makes them particularly useful for tasks such as iterating through a list of items or performing operations on multiple values at once. Hashes in Perl are data structures that store key-value pairs, allowing for efficient data retrieval using unique identifiers. The syntax for declaring a hash involves the % symbol followed by the hash name. For example, %student equals name equals Alice, grade equals A creates a hash with 2 key-value pairs. Here, name and grade are the keys, and Alice and A are their corresponding values. To access a value, you use the key within curly braces, such as student name, to retrieve Alice. Hashes are especially powerful for organizing data in a way that mirrors real-world relationships, such as mapping student names to their grades or storing configuration settings. Their ability to quickly look up values based on keys makes them a cornerstone of Perl programming. Perl's data types include scalars, arrays, and hashes, each serving distinct purposes in data manipulation. A scalar, represented by a $sign, holds a single value, such as x equals 42. Arrays, denoted by an @ symbol, store ordered lists of scalars, like at y equals 1, 2, 3 hashes, indicated by a % symbol. Manage key-value pairs, as seen in %z equals a equals 1, b equals 2. One of Perl's unique characteristics is its ability to automatically convert between data types when necessary. For instance, if a numeric value is used in a string context, Perl will convert it to a string without requiring explicit conversion. This feature simplifies coding, but also requires careful attention to avoid unintended results. Understanding these conversions is essential for writing robust and predictable Perl scripts. Variable scope in Perl determines where a variable can be accessed within a program. Global variables are available throughout the entire script, making them accessible from any part of the code. This can be convenient, but also risky, as changes to a global variable in one section of the program can affect other sections. In contrast, lexical variables declared using the my keyword are limited to the block, file, or scope in which they are defined. For example, my x equals 10 ensures that x is only accessible within the current block or file. Using lexical variables helps prevent naming conflicts and reduces the likelihood of unintended side effects. This practice is particularly valuable in larger programs where managing variable visibility becomes critical. Perl includes several special variables that serve specific purposes in programming tasks. The variable acts as a default variable for loops and functions, meaning it is often used implicitly when no other variable is specified. For example, in a for-each loop, represents each element of the list. The variable keeps track of the current line number in a file, which is useful when processing input line by line. The variable, known as the input record separator, defines how Perl reads lines from a file, with the default being a newline character. Lastly, the $$ variable stores the name of the current script, allowing programs to reference themselves dynamically. These special variables streamline common operations and reduce the need for additional code. In summary, variables are fundamental to Perl programming, enabling the storage and manipulation of data in diverse ways. Scalars, arrays, and hashes each provide unique capabilities for handling single values, lists, and key value pairs, respectively. By understanding these types and their contexts, you can write more efficient and readable code. Using the My keyword to declare lexical variables helps maintain clean and predictable code by limiting their scope. Additionally, Perl's special variables simplify tasks such as file processing, loops, and dynamic script referencing. Mastering these concepts will empower you to build robust and flexible Perl programs tailored to a wide range of applications. Operators are symbols that perform operations on variables and values. For example, when you use a plus sign, it adds two numbers together. An expression is a combination of operators and operands that produces a result. Think of it like a mathematical equation where you have numbers and symbols working together. Understanding operators and expressions is essential for writing effective Perl code because they form the foundation of any program. Without them, you can't perform calculations, make decisions, or manipulate data. Whether you're adding numbers, comparing values, or building complex logic, operators are the tools that make it all possible. The arithmetic operators include addition, subtraction, multiplication, division, modulus, and exponentiation. Addition combines two numbers, like 5 plus 3. Subtraction takes one number away from another, such as 10 minus 4. Multiplication scales numbers, for instance, 6 times 2. Division splits a number into equal parts, like 8 divided by 2. The modulus operator returns the remainder of a division, so 7 mod 3 gives 1. Exponentiation raises a number to a power, such as 2 to the third power. These operators are the building blocks for calculations in Perl, allowing you to handle everything from simple math to complex scientific computations. Comparison operators are used to compare values and determine relationships between them. Equal to checks if two values are the same, like 5 equals 5. Not equal to verifies if values differ, such as 4 not equal to 3. Greater than and less than compare which value is larger or smaller. For example, 6 greater than 2 or 3 less than 7. The greater than or equal to and less than or equal to operators expand on this by including equality, like 9 greater than or equal to 9 or 5 less than or equal to 5. These operators are crucial for decision-making in programs, helping you control the flow of your code based on conditions. Logical operators allow you to combine or invert Boolean expressions. The logical AND operator returns true only if both conditions are true, such as 1 and 0. The logical OR operator returns true if at least one condition is true, like 0 or 1. The logical NOT operator inverts the truth value of a condition, so not 0 becomes true. These operators are essential for creating complex conditions in your code, enabling you to write more sophisticated logic. For instance, you might use them to check multiple criteria at once, ensuring your program behaves as intended under various circumstances. Assignment operators are used to assign values to variables. The simple assignment operator equals assigns a value directly, like setting x to 5. The addition assignment operator plus equals adds a value to the existing variable, such as x plus 3. Subtraction assignment minus equals subtracts a value from the variable. Multiplication assignment times equals multiplies it. And division assignment slash equals divides it. These operators streamline your code, making it more concise and easier to read. Instead of writing x equals x plus 3, you can simply use x plus equals 3. This shorthand is widely used in Perl to improve efficiency. string operators handle operations on text. The concatenation operator dot joins two strings, like hello and world, becoming hello world. The repetition operator X repeats a string a specified number of times, so a times 3 results in AAA. Perl also provides string comparison operators, such as EQ for equality, NI for not equal, LT for less than, and GT for greater than. These operators are vital for working with text data, allowing you to manipulate and compare strings in ways that numeric operators cannot. Understanding these tools helps you process and analyze textual information effectively. Operator precedence and associativity determine the order in which operations are performed. Precedence defines which operators are evaluated first, such as multiplication taking priority over addition. Associativity dictates how operators of the same precedence are grouped, either from left to right or right to left. For example, in an expression like 2 plus 3 times 4, multiplication happens first due to higher precedence. Parentheses can override these rules, ensuring the desired order of evaluation. Mastering this concept is critical to avoid errors and ensure your code behaves as expected, especially in complex expressions. Operators and expressions are fundamental to Perl programming. Mastery of arithmetic, comparison, logical, and assignment operators is critical for writing functional and efficient code. Understanding precedence and associativity ensures that your expressions evaluate correctly, preventing unexpected results. Practicing by writing and evaluating expressions helps you become more proficient, allowing you to tackle more advanced programming tasks. Whether you're building simple scripts or complex applications, a solid grasp of operators and expressions will empower you to solve problems effectively and creatively. Control structures are the foundation of program logic, determining the order in which instructions are executed. They allow programs to make decisions and repeat actions, which are essential for handling complex tasks. The two main types are conditional structures, such as if, else, if, and else, and iterative structures, such as loops. These structures enable programmers to create dynamic and responsive scripts by controlling the flow of execution based on specific conditions. Understanding control structures is crucial for writing efficient and effective Perl programs. The if statement is a fundamental conditional structure that allows code to execute only when a specified condition is true. The syntax for the if statement is straightforward, beginning with the keyword if followed by a condition in parentheses and a block of code enclosed in curly braces. For example, if the variable x is greater than 5, the script will print the word greater. In Perl, conditions evaluate to true or false, with true represented by any non-zero or non-empty value, and false represented by 0 or an empty string. This makes the if statement a powerful tool for directing program behavior. To handle multiple conditions, Perl provides the else if clause, which allows for additional checks after an initial if statement. The else clause serves as a default option when none of the preceding conditions are met. For instance, if the variable x is greater than 10, one action occurs, but if x is greater than 5, a different action is taken. If neither condition is satisfied, the else block executes. This hierarchical structure ensures that programs can make logical decisions based on a series of criteria, making the code more organized and easier to maintain. The while loop is an iterative structure that repeats a block of code as long as a specified condition remains true. The syntax begins with the keyword while, followed by a condition in parentheses and a code block in curly braces. For example, a loop might print the value of the variable I until it reaches 5, incrementing each time. However, care must be taken to ensure the condition eventually becomes false, as an unchanging condition can lead to an infinite loop. Understanding how to manage loop conditions is critical for avoiding unintended program behavior. The for loop is another iterative structure that is particularly useful for scenarios where the number of iterations is known in advance. It consists of 3 parts: initialization, condition, and increment, all separated by semicolons. For example, a for loop can initialize the variable I to 0, continue while I is less than 3, and increment I by 1 each iteration. This structure is ideal for tasks such as iterating through a fixed range of values, making it a versatile tool for repetitive tasks in Perl. The for each loop is designed to iterate over elements in a list or array, simplifying the process of processing each item sequentially. The syntax involves the keyword for each followed by a variable to hold each element, and the list or array to iterate over. For instance, a for-each loop can print each number in a list of 1, 2, and 3. This structure eliminates the need for manual index management, making array traversal more efficient and readable. It is a preferred method for working with collections of data in Perl. Loop control statements provide additional flexibility for managing the execution of loops. The next statement skips the current iteration and moves to the next one, while the last statement exits the loop entirely. The redo statement restarts the current iteration without checking the loop condition again. For example, a loop might skip processing when a variable equals 0, exit if the variable exceeds 10, or restart if a specific condition is met. These statements allow for precise control over loop behavior, enhancing the adaptability of Perl scripts. Mastering control structures is essential for writing effective Perl programs. Conditional statements like if, else if, and else allow for decision-making, while loops enable repetition of tasks. These structures work together to create complex logic, making scripts more dynamic and efficient. Practicing with real-world examples helps reinforce these concepts, leading to better code organization and problem-solving skills. By understanding and applying control structures, programmers can build robust and readable Perl applications. Functions and subroutines are reusable blocks of code that allow you to encapsulate logic and execute it multiple times throughout your program. This approach enhances modularity, making your code easier to manage, test, and maintain. By breaking down complex tasks into smaller, self-contained units, you can focus on one specific purpose at a time. In Perl, subroutines are defined using the sub keyword, which signals the start of a named block of code. Functions, on the other hand, can be either built in, like print or split, or user-defined, giving you the flexibility to create custom operations tailored to your needs. This distinction is important because it allows you to leverage existing tools while also extending the language to suit your requirements. To define a subroutine in Perl, you use the sub keyword followed by a name and a block of code enclosed in curly braces. For example, the subroutine greet is defined with subgreet print hello world \n, which outputs a message when called. Subroutines can be invoked simply by using their name, such as greet, and they execute the code within their block. This syntax is straightforward and mirrors the way functions are structured in many programming programming languages. It's worth noting that Perl allows you to call subroutines with or without parentheses, depending on your preference, which adds a layer of flexibility to how you structure your code. In Perl, arguments passed to a subroutine are stored in a special array called at which is accessible within the subroutine. This array holds all the values provided when the subroutine is called, making it easy to work with multiple inputs. For instance, the add subroutine takes two arguments by assigning them to A and B using my A. B equals at this approach ensures that the values are properly scoped and accessible within the subroutine. Alternatively, you can directly reference the elements of at to perform operations, though assigning them to variables is generally preferred for clarity and maintainability. Understanding how to access and manipulate arguments is crucial for building flexible and dynamic subroutines. Subroutines in Perl return the value of the last evaluated expression, which means that even without an explicit return statement, the final line of code in the subroutine is automatically returned. This behavior can be leveraged to simplify your code, but it's often better to use the return keyword for clarity, especially when you need to exit a subroutine early. For example, the multiply subroutine returns the product of X dollars and Y, which is calculated and returned as the final expression. By explicitly using return, you make your intentions clear to other developers and reduce the risk of unintended behavior. This practice is particularly useful in complex subroutines where multiple return points might exist. Subroutines in Perl can access global variables unless they are explicitly declared with the my keyword, which creates a lexical scope. This means that if a subroutine references a variable defined outside its block, it will use the global value unless a local variable with the same name is declared inside the subroutine. For example, the display subroutine prints the value of global, which is defined outside the subroutine. However, using my to declare variables within a subroutine ensures that they are confined to that scope, preventing unintended side effects and reducing the likelihood of naming conflicts. This distinction is vital for writing clean, predictable code that is easier to debug and maintain. Following best practices when writing subroutines is essential for creating robust and maintainable Perl programs. One key principle is to use the my keyword for local variables to avoid accidental modifications of global variables, which can lead to hard-to-trace bugs. Another is to keep subroutines focused on a single task, ensuring that each function has a clear and specific purpose. This makes your code more modular and easier to test. Additionally, documenting your subroutines with comments or Perl's plain old documentation pod format helps others understand their functionality and usage. Finally, minimizing the use of global variables reduces dependencies and improves the overall structure of your program, making it more scalable and easier to manage. Let's look at an example of a simple function that calculates the factorial of a number. The factorial subroutine uses recursion, where the function calls itself with a modified argument until it reaches a base case. In this example, the subroutine takes a single argument, n, which is retrieved using the shift function. If n is 0, the subroutine returns 1, which is the base case for factorial calculations. Otherwise, it multiplies n by the result of factorial $n-1. This recursive approach demonstrates how subroutines can handle complex operations by breaking them into smaller, manageable steps. When called with factorial 5, this subroutine returns 120, illustrating the power of recursive functions in solving mathematical problems. A parameterized subroutine is one that accepts multiple arguments, allowing it to perform actions based on the inputs provided. For instance, the displayInfo subroutine takes 2 arguments, name and age, which are assigned from the array. These values are then used to print a formatted message, such as name, Alice, age, 30, when the subroutine is called with those parameters. This flexibility enables you to create subroutines that adapt to different scenarios, making your code more versatile. By carefully structuring how arguments are passed and processed, you can ensure that your subroutines are both efficient and easy to use in various contexts. Error handling is a critical aspect of writing reliable Perl programs, and subroutines provide tools like die and warn to manage unexpected situations. The die function is used to terminate the program and display an error message, which is particularly useful for critical issues like division by 0. For example, the divide subroutine checks if the second argument is 0, and if so, calls die with a message indicating the problem. This prevents the program from continuing with invalid data. In contrast, warn outputs outputs a warning message without terminating the program, allowing for more graceful error recovery. These mechanisms help you identify and address issues early, improving the stability and user experience of your applications. In Perl, the terms functions and subroutines are often used interchangeably, though they have subtle differences. Built-in functions like print or split are part of the Perl language and are typically called without parentheses, though they can also be used with them. Subroutines, on the other hand, are user-defined blocks of code that you create using the sub keyword. Both functions and subroutines can be called with or without parentheses, which adds flexibility to how you structure your code. This interchangeability allows you to design your programs in a way that feels natural and intuitive, whether you're using existing tools or creating your own. Understanding this distinction helps you make informed decisions about how to organize and structure your code. To summarize, functions and subroutines are fundamental to writing organized, efficient, and maintainable Perl programs. By mastering how to pass parameters, handle return values, and manage variable scope, you can create code that is both powerful and easy to understand. Applying best practices, such as using my for local variables, keeping subroutines focused, and documenting your work ensures that your programs remain scalable and adaptable. As you continue to practice, you'll find that these concepts form the backbone of effective Perl development, enabling you to build complex applications with confidence and clarity. Arrays and hashes are fundamental data structures in Perl. They serve as the backbone for organizing and managing data within programs. Arrays store ordered lists of scalar values, meaning each element has a specific position, starting from 0. This makes them ideal for sequences like lists of numbers, strings, or even other data structures. Hashes, on the other hand, store unordered key-value pairs, allowing you to retrieve values based on unique keys rather than numerical indices. This makes them perfect for scenarios where you need to look up information quickly, such as mapping usernames to their corresponding IDs. Both arrays and hashes are essential for managing complex data in programs, enabling you to handle everything from simple lists to intricate data relationships. Arrays are declared using the @sigil, which is the @symbol. For example, you can assign values to an array like this. @array equals 1, 2, 3. This initializes the array with 3 elements, Arrays can also be initialized with literals, variables, or expressions. For instance, if you have a variable containing a list of numbers, you can assign it directly to an array. Another common method is using the QW function, which creates a list of strings separated by spaces. For example, at names equals QW John Jane, Joe is equivalent to writing at names John, Jane, Joe. This shorthand is particularly useful for creating arrays of words or identifiers without needing to add quotes and commas manually. Elements in an array are accessed via their index, which is a numerical position starting from 0. The first element is always at index 0, the second at index 1, and so on. For example, if you have an array called at numbers with values 10, 20, 30, then number 0 would return 10. Negative indices are also allowed, which count from the end of the array. So numbers 1 would give you 30, the last element. This feature is handy when you need to access elements relative to the end of the array without knowing its exact length. Additionally, you can determine the number of elements in an array using the scalar function. For example, scalar at numbers returns 3, which is the count of elements in the array. Modifying arrays involves adding, removing, or changing elements. To add elements to the end of an array, you can use the push function. For example, push at array value appends a new value to the end. If you want to add elements to the beginning, the unshift function is used instead. Removing elements is equally straightforward. The pop function removes the last element, while shift removes the first. These operations are essential for dynamic data handling, such as processing a queue or stack. You can also modify specific elements by directly assigning a new value to their index. For instance, array 2, new value, changes the third element of the array to a different string. This flexibility allows arrays to adapt to various programming needs. Common array functions include sort, reverse, grep, and map. The sort function arranges the elements of an array in alphabetical or numerical order. For example, sort at array would return the elements sorted. The reverse function flips the order of elements, so the last becomes first, and vice versa. These functions are useful for organizing data in a specific sequence. The grep function filters elements based on a condition, allowing you to extract only those that meet a certain criterion. For instance, grep $5 at numbers would return all numbers greater than 5. The map function transforms each element in the array, applying a block of code to every item. This makes it ideal for tasks like converting strings to uppercase or performing calculations on numerical values. Together, these functions provide powerful tools for manipulating arrays. Hashes store key-value pairs, which are like dictionaries, where each key is associated with a specific value. This structure allows for efficient lookups, as you can retrieve a value by its key rather than searching through the entire dataset. For example, a hash might be used to store user information, where the keys are usernames and the values are their corresponding details. Keys in a hash are always strings, while values can be scalars or even references to other data structures. This versatility makes hashes suitable for a wide range of applications, from configuration files to database-like structures. The unordered nature of hashes means that the order of key-value pairs is not guaranteed, but this does not affect their functionality. Hashes are declared using the hash sigil, which is the percent symbol. The syntax for initializing a hash is %hash equals key 1, value 1, key 2, value 2. The arrow operator equals is used to separate keys from their corresponding values, making the code more readable. Another way to initialize a hash is by using the QW function, which creates a list of alternating keys and values. For example, %hash equals QW name Alice age 30 is equivalent to writing %hash equals name equals Alice, age equals 30. This method is particularly useful when dealing with simple key-value pairs without needing to add quotes or commas. Both approaches allow for flexible and concise hash initialization. Accessing elements in a hash is done through their keys, which are specified using curly braces. For example, hash name would return the value associated with the key name. This method is straightforward and efficient, making it easy to retrieve specific data. It is important to note that keys are case-sensitive, so name and name would be treated as different keys. To check if a key exists in a hash, you can use the exists function, which returns true if the key is present. Additionally, the defined function can be used to verify if a key has a defined value, which is useful for distinguishing between a missing key and a key with an undefined value. These tools help ensure data integrity when working with hashes. Modifying a hash involves adding, updating, or removing key-value pairs. To add or update an entry, can assign a new value to a key, such as #nuki equals value. This operation is simple and intuitive, making it easy to manage dynamic data. Removing a key value pair is done using the delete function, which removes the specified key and its associated value from the hash. For example, delete hash key would eliminate that entry. To retrieve all keys or values from a hash, you can use the keys and values functions, respectively. These functions return lists of all keys or values, which can be useful for iterating through the hash or performing bulk operations. Understanding these methods is crucial for effectively manipulating hash data. Common hash functions include keys, values, and each. The keys function retrieves all the keys in a hash, providing a list that can be used for iteration or further processing. Similarly, the values function returns all the values associated with the keys, which is useful for accessing the data stored in the hash. The each function allows you to iterate through key value pairs, returning one pair at a time. This is particularly helpful when you need to process each element of the hash in a loop. These functions are essential for working with hashes, enabling you to extract, manipulate, and analyze data efficiently. By combining these tools, you can perform complex operations on hash structures with ease. Arrays and hashes can be combined to create more complex data structures. For instance, an array can contain multiple hashes, allowing you to store a collection of related data. This is useful for representing records, such as a list of users where each user is a hash with keys like name and email. Conversely, a hash can map to an array, storing a list of values under a single key. For example, a hash might have a key list whose value is an array of numbers. This nesting capability is powerful for modeling real-world scenarios, such as databases or configuration files, where data is often structured in layers. By leveraging these combinations, you can build sophisticated data models that are both flexible and scalable. Arrays and hashes are core to Perl's data manipulation capabilities. Arrays handle ordered lists, making them ideal for sequences where the position of each element matters. Hashes, with their key-based access, are perfect for scenarios requiring quick lookups and associative storage. Mastery of these structures enables efficient and scalable Perl programming, allowing you to manage data with precision and flexibility. Whether you're processing large data sets, building complex applications or handling configuration files, understanding arrays and hashes is essential. By practicing their use in various contexts, you'll develop the skills needed to tackle a wide range of programming challenges effectively. File handling in Perl is a fundamental aspect of working with data stored in external files. It allows programmers to read information from files, modify it, and write it back, which is essential for tasks like data processing, logging, or configuration management. Perl offers a variety of built-in functions to perform these operations efficiently. Key concepts in file handling include file modes, which dictate how a file is accessed, file handles that act as references to open files, and I/O operations that handle the actual reading and writing of data. Understanding these elements is crucial for managing files effectively in Perl scripts. To begin working with a file in Perl, you use the open function. The syntax for this function is open filehandle mode file, where filehandle is a variable or a bear word that represents the file. Mode specifies the access type, and file is the name of the file. Common modes include for reading, for writing, which overwrites existing content, for appending to the end of a file, and plus for reading and writing. Choosing the right mode ensures that your operations behave as intended, whether you are creating a new file, modifying an existing one, or adding data without erasing what's already there. Reading from a file in Perl can be done using either the angle brackets file or the readline function. The angle brackets are often used in a while loop to process each line individually, which is efficient for large files. For example, a loop like while my line equals file, print line, reads each line and prints it. Alternatively, the readline function provides more control over the reading process. For scenarios where you need to read an entire file at once, the readfill function from the file slurp module simplifies this task. This approach is useful for small files or when quick processing is required, but it's important to note that it may not be suitable for very large files due to memory constraints. Writing to a file in Perl involves using the print function with a file handle. For instance, print file, this is a line, \n writes a line to the specified file. It's critical to ensure that the file handle is properly closed after writing to prevent resource leaks and ensure data is flushed to the file. Failing to close, a file can lead to incomplete writes or data corruption, especially if the program terminates unexpectedly. Always remember to close the file handle after completing all write operations, which helps maintain the integrity of the data and the system's resources. Understanding file modes is essential for controlling how files are accessed. The mode creates a new file or overwrites an existing one, making it ideal for scenarios where you want to start fresh. The mode appends data to the end of a file, preserving existing content, which is useful for logging or adding records. The mode allows reading from an existing file, and the plus mode enables both reading and writing, but it requires the file to already exist. Each mode serves a specific purpose, and selecting the correct one ensures that your operations are safe and efficient. Error handling is a critical aspect of file operations in Perl. When using the open function, it's essential to check whether the operation succeeded. A common practice is to use a conditional statement like openMyFH, file txt, or die cannot open file. This ensures that if the file cannot be opened, the program terminates gracefully and provides a meaningful error message. The variable contains the system-specific error message, which helps diagnose issues such as missing files or permission problems. Implementing robust error handling prevents unexpected behavior and improves the reliability of your scripts. File handles in Perl act as references to open files, allowing you to perform read and write operations. They can be either scalar variables or bare words, but using scalar variables is often preferred for clarity and avoiding naming conflicts. When working with multiple files, it's important to manage file handles carefully to prevent resource exhaustion. For example, after completing operations on a file, you should close the file handle using the close function. This practice ensures that system resources are freed up and that the file is properly saved, reducing the risk of data loss or corruption. In Perl, file operations often involve reading from or writing to standard input and output. The standard input file handle, often referred to as stdin, allows programs to accept input from the user or other processes. Similarly, the standard output file handle, stdout, is used to send output to the terminal or other destinations. These default file handles are automatically opened, making it easy to interact with users explicitly calling the open function. Understanding how to use these handles enhances the flexibility of your scripts, enabling them to process data dynamically. When working with files in Perl, it's important to consider the file's position. The tell function returns the current position of the file pointer, which is useful for tracking where you are in the file. The seek function allows you to move the file pointer to a specific location, enabling random access to data. These functions are particularly useful for large files where you need to jump to specific sections without reading the entire file. Proper use of tell and seek can optimize performance and allow for more complex data manipulation. Perl provides several functions to manipulate files, including renaming, deleting, and checking file attributes. The rename function allows you to change a file's name or move it to a different directory, while the unlink function deletes a file. The stat function retrieves information about a file, such as its size or modification time. These utilities are essential for managing files programmatically, enabling tasks like backup systems or file management tools. Familiarity with these functions enhances your ability to automate file-related tasks efficiently. Regular expressions are patterns used to match and manipulate text. They are essential for tasks like validation, searching, and replacing text. Perl provides robust support for regex with built-in operators and functions. Think of regular expressions as a powerful toolset for working with strings. For example, you can use them to check if a user's input matches a specific format, such as an email address or a phone number. They also allow you to search through large blocks of text to find specific patterns or replace parts of a string with something else. Perl's integration of regex into its core makes it particularly efficient for these tasks, as you don't need external libraries to perform complex text processing. Literals match exact characters, such as or 123. Meta characters are special symbols with predefined meanings, such as dot, asterisk, plus, and question mark. Character classes match any one of a set of characters, such as EU or digit. Literals are straightforward. They match exactly what you type. For instance, if you search for the letter A, it will only match the letter A. Meta characters, however, have special functions. The dot symbol matches any single character. The asterisk means 0 or more of the preceding element. The plus means 1 or more. And the question mark means 0 or 1. Character classes allow you to define ranges or sets of characters. For example, EU matches any vowel, while \D matches any digit. These elements combine to create flexible and precise patterns for text analysis. Use m// to check if a pattern matches a string. Example: string $m/pattern/ returns true if matched. Flags include I for case insensitive, G for global match, and S for treat string as single line. The M operator is used to perform a match. For example, if you have a variable called string and you want to check if it contains the word hello, you would write string = m hello if the pattern is found. This returns true. The I flag makes the match case insensitive, so it would match hello, hello, or hello. The G flag allows for global matching, meaning it finds all occurrences in a string rather than stopping after the first match. The S flag is useful when dealing with multi-line strings, as it treats the entire string as a single line, allowing the .meta character to match new line characters. Use s// to replace parts of a string. Example: string $s/ old new / replaces old with new. Flags include G for replace all occurrences, I for case insensitive replacement. The S operator is used for substitution. If you have a string that contains the word apple and you want to replace it with orange, you would write string = s/apple. Orange, this changes the first occurrence of apple. Adding the G flag ensures all instances are replaced, which is useful for modifying entire documents or datasets. The I flag allows for case-insensitive replacements, so it would match apple, apple, or apple. This is particularly helpful when working with user input or unstructured data where case variations are common. $D for digits, $W for word characters, $S for white space. Anchors include caret for start of string, $sign for end of string. Quantifiers include asterisk for 0 or more, plus for 1 or more, question mark for 0 or 1. The \D pattern matches any digit, making it useful for extracting numbers from text. The \W pattern matches word characters, which include letters, digits, and underscores, often used for identifying variables or identifiers. The \S pattern matches white space, such as spaces or tabs, which is helpful for cleaning up text. Anchors like caret and and $ define where a pattern must appear in a string. For example, hello matches hello only if it is at the start of a line, while hello matches it only if it is at the end. Quantifiers like asterisk, plus, and question mark control how many times a pattern can repeat, allowing for flexible matching of varying lengths. Regular expressions are powerful tools for text processing in Perl. Mastering syntax and operators enables efficient string manipulation. Practice with real-world examples to build confidence. Regular expressions are a cornerstone of Perl's capabilities, allowing developers to handle complex text tasks with concise code. By understanding the syntax and how operators interact, you can perform tasks like parsing log files, validating input, or transforming data with ease. However, regex can be tricky to master. The best way to become proficient is through practice. Try applying regex to real-world scenarios, such as extracting dates from a document or replacing outdated phrases in a text file. The more you experiment, the more intuitive it becomes, and the more confident you'll feel in using this essential tool. Today, we will delve into advanced regular expressions, exploring patterns that go far beyond simple matching. These techniques allow us to tackle complex text processing tasks with precision. We will examine look-aheads and look-behinds, which let us assert conditions without consuming characters. We will also explore recursive patterns for handling nested structures. Additionally, we will discuss optimization strategies to improve performance, and we will uncover advanced modifiers and flags that enhance regex flexibility. By mastering these concepts, you will gain the ability to solve intricate problems in Perl with confidence. Look-aheads and look-behinds are powerful assertions that help us check for patterns without altering the match. A positive look-ahead, denoted by question mark plus equal sign, ensures that a specific pattern follows the current position. For example, it can verify that a string ends with a certain sequence. Conversely, a negative look-ahead using question mark exclamation mark ensures that a pattern does not follow. These tools are invaluable for tasks like validating passwords or parsing structured data. Similarly, positive look-behinds check for patterns preceding the current position, while negative look-behinds ensure a pattern does not precede. These constructs allow us to build highly specific and context-aware regex patterns. Recursive patterns enable us to match nested or hierarchical structures, such as parentheses or tags. The syntax double question mark plus curly braces allows the regex engine to reevaluate the pattern dynamically. For instance, matching nested parentheses requires recursion to handle multiple levels of nesting. This technique is essential for parsing complex data formats like XML or mathematical expressions. By leveraging recursion, we can create regex that adapts to varying depths of structure, making it a cornerstone of advanced text processing in Perl. Optimization is critical when working with complex regex to ensure efficiency. Greedy quantifiers, which match as much as possible, can lead to excessive backtracking. To mitigate this, we use non-greedy quantifiers such as asterisk question mark or plus question mark, which match as little as possible. Precompiling regex with the QR operator improves performance when patterns are reused. Additionally, localized modifiers, denoted by question mark caret colon, restrict the scope of flags to specific parts of the regex. These strategies help reduce runtime and prevent unnecessary computational overhead. Incorporating variables into regex allows for dynamic pattern creation. The QR operator compiles a pattern into a regex object, which can then be interpolated into other patterns. For example, if a variable holds a string like ABC, interpolating it into a regex will match that exact sequence. However, special characters in variables can interfere with regex syntax. To safely interpolate, we use the \q\e construct, which escapes all special characters, ensuring the variable's content is treated as literal text. This approach is essential for building flexible and secure regex solutions. Advanced quantifiers provide fine-grained control over repetition in regex. The curly brace notation, such as NM, specifies exact ranges of matches, allowing us to enforce minimum and maximum lengths. Non-greedy quantifiers like asterisk question mark or plus question mark minimize backtracking by matching the least possible. Additionally, backtracking control verbs like star prune or star skip let us guide the regex engine's behavior, preventing it from revisiting failed paths. These tools are indispensable for crafting efficient and predictable regex patterns. Modifiers and flags enhance the functionality of regex by altering their behavior. The I flag enables case-insensitive matching, making patterns insensitive to uppercase or lowercase variations. The S flag treats the entire string as a single line, allowing the dot meta character to match newline characters. The X flag permits free spacing and comments, improving readability for complex patterns. Finally, the G flag enables global matching, allowing us to find all occurrences in a list context. These flags make regex more adaptable to diverse text processing needs. Let's apply these concepts to real-world scenarios. Validating email formats requires careful handling of domains, local parts, and special characters. Nested HTML tags can be extracted using recursive patterns to account for multiple layers of structure. Log files often contain repetitive patterns that can be efficiently parsed with look-aheads and look-behinds. Lastly, substitutions using the S operator with modifiers allow for precise text replacement. These examples demonstrate how advanced regex transforms abstract patterns into practical solutions for data manipulation. Debugging complex regex can be challenging, but Perl provides tools to simplify the process. The Ray debug module traces the regex engine's execution, revealing how each part of the pattern interacts. Inserting *fail in a regex can help identify problematic sections by forcing a match to fail. Printing intermediate results or using warnings allows us to inspect the state of the string during matching. Breaking down large regex into smaller, testable components ensures each part functions as intended, making troubleshooting more manageable. In conclusion, advanced regular expressions empower us to process text with remarkable precision and flexibility. Mastering look-aheads, look-behinds, and recursion unlocks the ability to handle nested and hierarchical data. Optimization techniques ensure our regex performs efficiently, while advanced modifiers and flags expand their utility. By practicing with real-world examples, you will refine your skills and apply these concepts to solve complex problems. Perl's robust regex capabilities make it a powerful tool for any text processing task. References in Perl are pointers to other data structures. This means they allow you to indirectly access variables, arrays, or hashes without working with the data directly. By using references, you can manage complex data more efficiently and reduce memory overhead. For example, Instead of duplicating large arrays or hashes, you can pass a reference to them, which saves resources. This is particularly useful when working with nested data structures or when passing large data sets to subroutines. References are a fundamental concept in Perl for building scalable and maintainable code. There are several types of references in Perl. Scalar references point to a single value, such as a number or string. Array references point to entire arrays, and hash references point to hashes. Subroutine references, on the other hand, point to functions or code blocks. Each type of reference serves a specific purpose. For instance, scalar references are useful for modifying variables indirectly, while array and hash references help manage collections of data. Subroutine references enable dynamic function calls, which can be powerful for creating flexible programs. Understanding these types is essential for working with advanced Perl features. Aiding references in Perl is straightforward. The backslash operator is used to create a reference to a variable, array, or hash. For example, arrayref \@ creates a reference to an array. Additionally, you can create anonymous references, which do not have a named variable. These are useful for quickly generating temporary data structures, such as ref equals 1, 2, 3. Anonymous references are often used in nested structures or when passing data directly to functions. Scalar references, like scalarf equals $value, allow you to work with individual values indirectly, which can be handy for modifying variables in different scopes. Dereferencing is the process of accessing the data that a reference points to. To dereference an array reference, you use the @ operator, and for scalar references, you use, for example, @array equals $arrayref retrieves the contents of the array pointed to by arrayref. Scalar dereferencing, like scalarf, allows you to retrieve the value of a scalar variable indirectly. When dealing with nested references, such as an array of hashes, you combine these operators. For instance, arrayref 0 accesses the first element of an array reference, and arrayref 0 key accesses a specific hash value within that array. Mastering dereferencing is crucial for working with complex data structures. Perl supports a variety of data structures, including arrays, hashes, and combinations of the two. References make it possible to create nested structures, such as arrays of hashes or hashes of arrays. For example, a hash reference can store a name, and an array of scores, like data equals name equals John, scores equals 85, 90, 78. This allows you to organize related data in a single structure, making it easier to manage and access. Nested references are particularly useful for modeling real-world data, such as databases or configuration files, where information is often grouped into hierarchical relationships. Nested data structures are a powerful feature of Perl. An array of hashes might look like an array equals A equals 1, B equals 2, where each element of the array is a hash reference. A hash of arrays, such as %hash equals key 1 equals 1, 2, key 2 equals 3, 4, allows you to store multiple values under a single key. When accessing nested references, you use a combination of dereferencing operators. For example, a reref0 key retrieves the value associated with key in the first hash of the array reference. These structures are ideal for representing complex data, such as a list of records or a collection of related values. Practical examples of references include storing configuration data in a hash reference, which allows you to organize settings in a structured way. Passing large arrays to functions via references avoids copying the entire array, which improves performance. Building a database-like structure using a hash of arrays enables efficient querying and data retrieval. References also help avoid unintended modifications to original data by allowing you to work with copies or indirect access. These techniques are essential for writing efficient, scalable Perl programs that handle large or complex datasets. Common pitfalls when using references include forgetting to dereference them before accessing data, which can lead to errors or unexpected results. Modifying the original data through a reference can have side effects, so it's important to be cautious when working with shared data. Using the use strict and use warnings pragmas helps catch these issues early. Debugging nested references can be challenging, but tools like Data Dumper provide a way to visualize the structure of complex data. By being mindful of these challenges, you can avoid common mistakes and write more reliable code. References are a cornerstone of advanced Perl programming. They enable the creation of complex data structures that would be difficult to manage otherwise. By mastering references, you can write more efficient, readable, and maintainable code. Practice creating and dereferencing references to build confidence in handling nested data. Applying references in real-world scenarios, such as configuration management or data processing, will further enhance your skills. With time and experience, you'll find that references are an indispensable tool for solving a wide range of programming challenges. Perl modules are like building blocks that allow developers to extend the functionality of the Perl programming language. These reusable code packages help organize code into logical units, such as math operations, file handling, or web services, making your code more structured and easier to manage. Modules are typically stored in the Perl library path, which is a directory where Perl looks for code, or in CPAN, which is a vast repository of modules. The benefits of using modules include code reuse, which saves time and effort, modularity that enhances code maintainability, and community-driven development that ensures a wide range of tools and continuous improvements. To use a module in Perl, you can employ the use statement, which is the most common way to import modules at the start of your script. For example, use module name loads the entire module. If you only need specific functions, you can import them using the QW operator, like use module, name QW function 1 function 2. This is particularly useful when you want to avoid loading unnecessary code. As an example, use strict and use warnings are often used together to enforce good coding practices and catch errors early. Additionally, modules can be loaded at runtime using the require function, which provides flexibility when you need to conditionally load code based on certain conditions. CPAN, or the Comprehensive Perl Archive Network, is a global repository that hosts over 20,000 modules for various tasks, such as database access, web development, and data analysis. It serves as a central hub where developers can share, download, and manage Perl modules. Beyond just code, CPAN includes comprehensive documentation, test suites to ensure reliability, and distribution tools that help with packaging and installation. You can access CPAN through the command line using the cpan tool, via a web interface, or through CPANPM, which is a module that simplifies the process of managing modules. This ecosystem ensures that Perl remains a powerful and versatile language. Installing modules via CPAN is straightforward and can be done using the cpan command in the terminal. For instance, typing cpan install DBI will automatically download and install the DBI module, which is essential for database interactions, along with any dependencies it requires. This dependency resolution is a key feature of cpan, as it ensures that all required modules are installed correctly. If you prefer a quieter installation process, you can use cpan imodule name to suppress unnecessary output. This makes it easier to integrate modules into scripts or projects without interruptions. For developers looking to create and distribute their own Perl modules, tools like Module, Install, and Dist, Zilla are invaluable. Module Install simplifies the process of generating the Makeful PL script, which is used to build and install modules. This reduces the amount of boilerplate code you need to write. Dist Zilla takes this a step further by automating tasks such as packaging, testing, and publishing modules to cpan. These tools help module authors focus on writing code rather than dealing with repetitive setup and maintenance tasks, ultimately streamlining the development workflow. When creating modules, following best practices ensures they are reliable and easy to use. Always test your modules thoroughly using tools like Prove or Test More, which help verify that your code works as expected. Assigning version numbers, such as 1, allows users to track changes and manage compatibility. Documenting your modules with tools like Pod, Usage, or PerlDoc makes it easier for others to understand and use your code. Additionally, avoiding global variables and instead using object-oriented or functional approaches can prevent unintended side effects and improve code clarity. Perl has a rich collection of modules that address common programming needs. The DBI module provides a consistent interface for database interactions, making it easier to work with different databases. Moose is a powerful object-oriented programming framework that simplifies class creation and inheritance. Carp helps with error message handling, allowing you to generate more informative warnings and errors. LWP is a library for making web requests, which is useful for interacting with web services. Finally, DateTime offers a robust set of tools for working with dates and times, handling time zones, and performing complex date calculations. When troubleshooting module issues, start by checking if the module is installed correctly using PerlDoc module name, which displays the module's documentation and confirms its presence. If dependencies are causing conflicts, tools like cpanum can help resolve them more efficiently than the standard cpan command. For deeper debugging, the cpan-d option provides detailed output to identify installation problems. Additionally, examining the meta JSON file in a module's distribution can reveal its requirements and dependencies, helping you understand what needs to be installed. These steps ensure that module-related issues are addressed systematically. Modules and cpan are essential components of the Perl ecosystem, enabling developers to build powerful applications without reinventing the wheel. By leveraging existing modules, you can save time and focus on solving specific problems rather than implementing generic functionality. Following best practices for module creation and maintenance ensures that your code is reliable and easy to share. Finally, exploring cpan opens up a world of possibilities, allowing you to extend Perl's capabilities for almost any task. Whether you are a beginner or an experienced developer, mastering modules and cpan will greatly enhance your Perl programming journey. Object-oriented programming, or OOP, is a programming paradigm that revolves around the concept of objects and classes. These objects are instances of classes, which act as blueprints for creating them. The 4 key principles of OOP are encapsulation, inheritance, polymorphism, and abstraction. Encapsulation refers to bundling data and methods that operate on the data within a single unit, while inheritance allows new classes to inherit properties and methods from existing ones. Polymorphism enables objects of different classes to be treated as objects of a common superclass. And abstraction simplifies complex systems by hiding unnecessary details. Perl supports OOP through its use of packages, which serve as classes, references that act as objects, and method calls that define behavior. This approach gives Perl a flexible yet powerful way to implement object-oriented concepts. In Perl, classes are defined using packages, which are essentially namespaces for grouping related functions and variables. Objects in Perl are typically references to hash or array structures, which store the data associated with the object. Methods, which are the functions that operate on these objects, are defined as subroutines within the package. The bless function is a crucial part of this process, as it associates a reference with a specific class, effectively turning it into an object. This mechanism allows Perl to dynamically determine which methods are available for an object based on its class. While Perl's approach to OOP is more manual compared to languages like Java or Python, it provides a high degree of flexibility and control over object behavior. To define a class in Perl, you start with a package declaration, such as package myClass, which creates a namespace for the class. Within this package, you define methods as subroutines, with the new method commonly serving as the constructor. The new method is responsible for creating and initializing an object, often by returning a blessed reference to a hash or array. For example, obj equals myClassNew instantiates an object of the myClass class. This process of creating objects through the new method is fundamental to Perl's object-oriented model, as it provides a standardized way to manage object creation and initialization. Methods in Perl are called using the arrow operator, which connects an object to a method, such as objMethod. This syntax is central to Perl's object-oriented programming, as it allows for clear and readable code. The new method, as a constructor, is typically used to create instances of a class. When a constructor is called, it often returns a blessed reference, which is an ordinary reference that has been tied to a specific class. This blessed reference becomes the object, and its methods are resolved based on the class it belongs to. Understanding how to implement and use constructors is essential for building robust Perl applications. Inheritance in Perl is implemented using the @isa array, which specifies the parent classes that a child class should inherit from. When a method is called on an object, Perl searches for that method in the class of the object, and then in the parent classes listed in @isa. This allows child classes to reuse and extend the functionality of their parents. To call a method from a parent class, the super method syntax is used, which directs Perl to look for the method in the parent class rather than the current one. This mechanism enables a hierarchical structure where classes can build upon each other, promoting code reuse and modularity. Polymorphism in Perl allows objects of different classes to be treated as objects of a common superclass, enabling a single interface to represent multiple types. This is particularly useful when working with collections of objects that share a common method but have different implementations. Method overriding occurs when a child class provides a specific implementation of a method that is already defined in its parent class. This allows for customization of behavior while maintaining a consistent interface. Perl also provides the can method, which checks whether a particular method exists in an object's class or any of its parent classes. This can be helpful for dynamically determining available functionality. While Perl's core OOP features are powerful, using modules like Moose or Moo can greatly enhance the development process. These modules provide advanced features such as attribute handling, method modifiers, and type constraints, making it easier to write clean and maintainable code. Encapsulation, a key OOP principle, is facilitated through accessors, getter, and setter methods that control how data is accessed and modified. This helps prevent unintended side effects and ensures data integrity. Additionally, adhering to best practices, such as using strict and warnings directives, helps catch potential errors early, leading to more reliable and safer code. These tools and techniques are essential for building complex object hierarchies in Perl. Perl's object-oriented programming model is both flexible and powerful, but it requires careful design to avoid common pitfalls. Understanding how packages, the bless function, and inheritance work is critical for effectively implementing OOP in Perl. While the language does not enforce strict OOP rules, its dynamic nature allows for creative solutions. However, for more complex applications, leveraging modules like Moose or Moo can simplify development and improve code quality. By following best practices and taking advantage of Perl's built-in features, developers can create robust, scalable, and maintainable object-oriented programs. Good day. Today, we will explore advanced object-oriented programming concepts in the Perl programming language. This presentation will cover inheritance, polymorphism, encapsulation, and design patterns. These principles are fundamental to building robust, scalable, and maintainable software in Perl. We will delve into how Perl implements these concepts and discuss best practices to leverage their full potential. Let us begin by examining inheritance, a cornerstone of object-oriented design. In Perl, inheritance allows classes to inherit methods and properties from other classes. This is typically achieved using the @ISA array or the use parent pragma. When a subclass is defined, it automatically gains access to all the methods and data members of its superclass. For example, by writing package child, use parent parent, the child class inherits all the functionality of the parent class. However, subclasses can also override methods to provide specialized behavior. This flexibility enables code reuse while allowing for customization, making it easier to manage complex hierarchies of classes. Polymorphism is another key concept, enabling objects of different classes to be treated as instances of a common superclass. This is particularly useful when working with collections of objects that share a common interface. Method overriding is a technique where a subclass provides its own implementation of a method defined in the superclass. Perl handles this dynamically, resolving the correct method at runtime based on the object's actual class. This dynamic dispatch allows for more flexible and adaptable code, as the same method call can behave differently depending on the object's type. Encapsulation is the practice of hiding an object's internal data and exposing only necessary functionality through accessor methods. In Perl, this can be achieved using closures or package-based data structures. By defining getters and setters, we control how data is accessed and modified, preventing unintended side effects. For instance, the new method in a class often initializes an object, while getProperty methods retrieve specific attributes. This separation of data and behavior enhances security, simplifies maintenance, and promotes modular design. Roles and mixins offer a way to define reusable behavior that can be composed into classes. Unlike traditional inheritance, roles are more like interfaces that specify a set of methods. Modules such as moose or role. Tiny provide tools to implement roles, allowing multiple roles to be combined into a single class. This approach promotes code reuse without the complexities of deep inheritance hierarchies. For example, a role might define a logging mechanism that can be applied to any class, enhancing its functionality without modifying its existing structure. When multiple inheritance is used, Perl employs the C3 linearization algorithm to determine the method resolution order. This ensures a consistent and predictable sequence for searching methods in a class hierarchy. The MRO getLinearisa function can be used to inspect this order, which is crucial for avoiding conflicts when multiple parent classes define the same method. Understanding the MRO helps developers design class hierarchies that are both efficient and free from ambiguity, especially in complex applications. Tying and overloading are advanced features that allow variables and objects to exhibit custom behavior. The tie function binds a variable to an object, enabling it to respond to operations like fetch or store. Overloading, on the other hand, lets objects support operators such as plus or equality. For example, overloading the stringification operator allows an object to return a meaningful string representation when used in a context that requires a string. These features make Perl objects more versatile and intuitive to work with. Design patterns provide proven solutions to recurring problems in software design. In Perl, common patterns include the singleton, which ensures a class has only one instance, the factory, which centralizes object creation, the observer, which decouples objects through event-driven communication, and the decorator, which dynamically adds behavior to objects. By applying these patterns, developers can create code that is more modular, easier to test, and adaptable to future changes. Perl's flexibility and closures make it well suited for implementing these patterns effectively. Adhering to best practices is essential for writing clean and maintainable Perl OOP code. Avoiding tight coupling between classes by favoring composition over inheritance reduces dependencies and improves flexibility. Using the strict and warnings pragmas helps catch common errors during development. Additionally, thorough documentation of methods and classes ensures that others can understand and extend the code. These practices, when combined, lead to more reliable and scalable applications. In conclusion, mastering advanced object-oriented programming concepts in Perl empowers developers to create sophisticated and efficient software. By understanding inheritance, polymorphism, encapsulation, and design patterns, you can build systems that are both powerful and easy to maintain. Remember that practice and experimentation are vital to refining your skills. As you apply these principles, you will unlock the full potential of Perl's object-oriented capabilities. Thank you for your attention. Tied variables in Perl offer a powerful mechanism to associate a variable with a class, allowing you to customize how that variable behaves. This means that when you perform operations like fetching or storing values, Perl delegates those tasks to the methods defined in the class. This feature is particularly useful for creating data abstractions, where you can encapsulate complex logic behind simple variable access. For instance, you might use tied variables to automatically log every time a value is retrieved or modified, or to enforce specific validation rules before storing data. By leveraging tied variables, you can make your code more modular and maintainable, as the internal workings of the variable are hidden behind a well-defined interface. When a variable is tied, Perl essentially hands over control of its operations to a custom class. This class must implement specific methods to handle different actions. For example, the tie method is called when the variable is tied, and it initializes the object. The fetch method retrieves a value, while the store method sets a value. These methods act as the bridge between the variable and the underlying class. To illustrate, imagine tying a hash to a class that stores data in a database. Every time you access or modify a key in the hash, the corresponding methods in the class would handle the database interactions, making the process seamless for the user. This delegation model allows for dynamic and flexible variable behavior. The tie module in Perl provides a set of base classes that make it easier to create tied variables. These include tie, scalar for scalars, tie, array for arrays, and tie, hash for hashes. Each of these modules offers a foundation for defining custom behavior. The tie function is used to bind a variable to a class, establishing the connection between the variable and the methods in the class. Conversely, the untie function breaks this connection, returning the variable to its default behavior. By using these modules, developers can avoid reinventing the wheel, as they provide the necessary scaffolding for implementing tied variables. This simplifies the process of creating custom data structures with unique properties. Let's look at a concrete example of tied variables in action. Suppose you have a hash that you want to tie to a custom class. The code would begin with the tie function, such as tie%hash, my class. This line links the hash to the myClass class. The class must then define specific methods to handle the hash operations. For a tied hash, the class needs to implement tie, sh, fetch, and store methods. The tie, sh method initializes the object, fetch retrieves values, and store sets values. Without these methods, the tied hash would not function correctly. This example demonstrates how tied variables can be used to encapsulate complex logic, such as storing data in a file or applying transformations to values before they are accessed. Tied variables have a wide range of practical applications that can enhance your Perl programs. One common use is logging access to variables, which is invaluable for auditing or debugging purposes. For example, every time a value is retrieved or modified, the fetch or store methods can record the action in a log file. Another application is input validation, where the store method can check that the data being stored meets certain criteria, such as a specific format or range. Additionally, tied variables can be used for lazy loading, where data is only fetched when it is actually needed, improving performance by avoiding unnecessary computations. These examples highlight how tied variables can be tailored to meet specific requirements in your code. While tied variables are powerful, there are several common pitfalls to avoid. One of the most frequent issues is forgetting to implement required methods, such as fetch or store, which can lead to runtime errors or unexpected behavior. It is also crucial to ensure that the methods return the correct values, as incorrect return values can cause the tied variable to malfunction. Another trap is overusing tied variables for simple tasks, which can introduce unnecessary complexity and performance overhead. For instance, using a tied variable for a straightforward scalar value might be overkill compared to a regular variable. It is important to weigh the benefits of tied variables against their complexity and use them judiciously. In summary, tied variables in Perl provide a flexible way to customize the behavior of variables through custom classes. The tie module offers essential tools to simplify the creation of these variables, making it easier to implement complex logic. While tied variables are particularly useful for advanced data handling tasks, such as logging, validation, and lazy loading, they should not be used indiscriminately, overcomplicating your code with tied variables when simpler solutions exist can lead to maintenance challenges. By understanding their capabilities and limitations, you can effectively leverage tied variables to enhance your Perl programs without introducing unnecessary complexity. Threads enable parallel execution of code within a single program. This means that multiple parts of a program can run at the same time, improving efficiency. Concurrency allows multiple tasks to proceed simultaneously, which is especially useful for handling I/O operations or long-running processes without freezing the entire application. Perl supports threading via the Threads module, which provides the necessary tools to create and manage threads. The key benefits include improved performance, as tasks can be processed in parallel, increased responsiveness, so the program remains interactive even during heavy processing, and better resource utilization, making the most of available system resources. A thread is a lightweight process within a program, meaning it requires less overhead than a full process. Threads share memory and resources of the parent process, which allows them to communicate and share data more efficiently. In Perl, threads are created using threads new, which is a function that spawns a new thread. Each thread runs independently, but they can communicate via shared variables, which are variables that all threads can access. However, this shared access must be managed carefully to avoid conflicts. Perl uses a threading model where threads are separate processes, which means each thread has its own memory space. This is different from some other languages where threads share memory by default. The Threads module provides thread creation and management, offering functions to start, pause, and terminate threads. To enable shared variables between threads, the Threads shared module is used, which allows variables to be accessed across different threads while maintaining control over their behavior. Creating threads in Perl involves using threads new with a subroutine reference and any arguments. For example, my thread equals threads new sub creates a new thread that executes the provided code. Another example is my thread equals threads new and subroutine at args, which starts a thread by calling a specific subroutine with given arguments. Threads can return values via the join method, which waits for the thread to finish and retrieves its result. However, modifying shared data without synchronization can lead to unpredictable results. So careful management is essential. Synchronization and locking are critical when working with shared data. The lock function from threads shared is used to protect shared data, ensuring only one thread can access it at a time. For instance, lock shared var prevents race conditions, where multiple threads try to modify the same data simultaneously. The cond wait and cond signal functions help coordinate threads, allowing them to wait for specific conditions to be met before proceeding. However, overusing locks can cause deadlocks, where threads are stuck waiting for each other, or performance issues due to excessive contention. Shared variables require the shared attribute to be accessible across threads. For example, my shared var shared declares a variable that can be modified by multiple threads. Using threads, shared clone allows for deep copies of data structures, ensuring that each thread has its own version if needed. It is important to avoid modifying non-shared variables in threads, as this can lead to unexpected behavior or errors. Proper use of shared variables ensures data integrity while leveraging the benefits of concurrency. Common pitfalls in Perl threading include forgetting to lock shared variables, which can result in race conditions and corrupted data. Threads may also fail to terminate properly if not joined, leaving the program in an unstable state. Excessive thread creation can overwhelm system resources, leading to performance degradation or crashes. Additionally, Perl's threading model is not as efficient as in some other languages, such as Java or C++, due to its design choices and the overhead of managing separate processes. Awareness of these issues is crucial for writing reliable threaded code. Best practices for Perl threading involve minimizing shared data to reduce complexity and the risk of conflicts. Using join ensures threads complete their tasks before the program exits, preventing premature termination. For safe inter-thread communication, the thread queue module is recommended, as it provides a structured way to pass data between threads. Thorough testing is essential to identify and resolve race conditions and deadlocks, ensuring the program behaves predictably under various scenarios. Following these practices leads to more robust and efficient threaded applications. Threads and concurrency significantly enhance Perl's capabilities for handling parallel tasks, making it suitable for applications that require simultaneous processing. Proper synchronization and shared data management are critical to avoid common issues like race conditions and deadlocks. Perl's threading model requires careful handling due to its unique approach to memory and resource management. By applying best practices, developers can create reliable and efficient code that leverages the power of concurrency while minimizing risks. Perl is a versatile language for web development, due to its text processing capabilities. Its strength in handling and manipulating text makes it ideal for tasks like parsing data, generating dynamic content, and managing complex data formats. Common use cases include CGI scripts, which allow Perl to interact with web servers, server-side scripting for dynamic web pages, and API development for creating web services. The Perl ecosystem offers a rich collection of modules that simplify tasks such as building web frameworks, integrating with databases, and implementing security measures. These tools ensure that Perl remains a powerful and flexible choice for developers working on web projects of varying complexity. CGI, or the Common Gateway Interface, enables Perl scripts to communicate with web servers, allowing them to process form data, generate HTML dynamically, and respond to user interactions. This interface acts as a bridge between the web server and the script, making it possible to create interactive web applications. ModPerl, on the other hand, embeds the Perl interpreter directly into the Apache web server, significantly improving performance by reducing the overhead of starting a new Perl process for each request. This approach is particularly beneficial for high-traffic websites where speed and efficiency are critical. Examples of its use include handling form submissions, generating real-time content, and managing user sessions. Perl offers several web frameworks tailored to different needs. Dancer is a lightweight framework that provides a simple and intuitive syntax, making it suitable for small to medium-sized applications. Its minimalistic design allows developers to quickly prototype and deploy web services. Modulicious stands out as a modern framework with built-in support for real-time features such as WebSockets and asynchronous processing, making it ideal for applications requiring instant updates or high concurrency. Catalyst, a more robust framework, follows the Model View Controller pattern and is designed for large-scale applications, offering scalability and flexibility through its modular architecture. Each framework has its strengths, enabling developers to choose the right tool for their specific project requirements. The DBI module serves as a universal interface for connecting Perl to various databases, including MySQL, PostgreSQL, and SQLite. This module provides a consistent API for executing SQL queries in inserting records, updating data, and retrieving results, regardless of the underlying database system. By abstracting the differences between database drivers, DBI simplifies database interactions and enhances code portability. Additionally, ORM tools like DBIX class allow developers to work with databases using object-oriented programming principles, reducing the need for raw SQL and improving code maintainability. These features make database integration in Perl both powerful and accessible for developers of all skill levels. Security is a critical aspect of web development, and Perl provides tools to address common vulnerabilities. Validating and sanitizing user inputs is essential to prevent attacks such as SQL injection and cross-site scripting. Modules like CGI, application and modulicious, plugin, secure headers help enforce security best practices by filtering inputs and setting secure HTTP headers, implementing authentication mechanisms such as password hashing and token-based sessions ensures that only authorized users can access sensitive parts of an application. By combining these techniques, developers can create robust and secure web applications that protect both user data and system integrity. Handling HTTP requests and responses is fundamental to web development, and Perl provides multiple ways to achieve this. Scripts can process GET and POST requests to retrieve data from users or send responses back to clients. Using the CGI module or framework-specific methods, developers can parse query parameters, extract form data, and generate dynamic content. For example, returning JSON data for AJAX requests allows web pages to update content without reloading, enhancing user experience. This flexibility enables Perl to support a wide range of web interactions, from simple form submissions to complex API integrations. Deploying Perl web applications requires careful consideration of server configurations and performance optimization. Common deployment options include using Apache or Nginx as web servers, or running standalone servers for simplicity. ModPerl enhances performance by embedding Perl into the server, while caching mechanisms and asynchronous processing further reduce response times. Tools like Devel, NYT-Prof help identify bottlenecks by profiling code execution, allowing developers to fine-tune their applications. By leveraging these techniques, Perl applications can handle high traffic loads efficiently while maintaining reliability and scalability. Adhering to best practices ensures that Perl web applications are maintainable, secure, and efficient. Using the strict and warnings, pragmas, helps catch potential errors during development, reducing runtime issues. Modularizing code by organizing it into reusable Perl modules promotes code reuse and simplifies maintenance. Leveraging CPAN modules extends functionality without reinventing the wheel, while following res tful principles ensures APIs are intuitive and scalable. These practices not only improve code quality, but also make it easier for teams to collaborate on complex projects. Real-world examples demonstrate Perl's versatility in web development. A blog engine built with Dancer and SQLite showcases how to create a simple yet functional content management system, handling posts, comments, and user interactions. A REST API for a product inventory system illustrates how Perl can power data-driven applications, enabling clients to retrieve and update product information via HTTP requests. Developing a chat application using Modulicious and WebSockets highlights Perl's ability to support real-time communication, demonstrating its relevance in modern web architectures. These examples underscore Perl's adaptability to diverse project requirements. Perl remains a powerful tool for web development, offering a rich ecosystem of modules and frameworks that cater to both small and large-scale applications. Emphasizing security, scalability, and best practices ensures that Perl-based web applications meet modern standards and perform reliably. The comprehensive Perl Archive Network, CPAN, provides an extensive library of modules, allowing developers to extend functionality quickly and efficiently. By leveraging Perl's strengths and staying informed about best practices, developers can create robust, secure, and innovative web solutions that stand the test of time. Databases are essential for storing and retrieving structured data, which is a fundamental aspect of modern software development. Whether you're managing user information, transaction records, or configuration settings, databases provide an organized way to handle large volumes of data efficiently. Perl, a versatile programming language, offers the DBI module, which stands for Database Interface. This module acts as a bridge between Perl and various database systems, allowing developers to interact with databases in a consistent and standardized way. The DBI module supports a wide range of databases, including MySQL, PostgreSQL, SQLite, Oracle, and many others. This session will guide you through the process of connecting to databases, executing queries, and managing data using Perl, ensuring you can work with different database systems seamlessly. To establish a connection to a database in Perl, we use the DBI Connect method, which requires specific parameters. The first parameter is the data source name, or DSN, which includes the database type, name, host, and other details. For example, the DSN DBI MySQL database equals test host equals localhost specifies a MySQL database named test hosted on the local machine. The next parameters are the username and password for the database. It is crucial to handle errors during this process to ensure robustness. If the connection fails, using the die function will immediately terminate the program and display an error message. Alternatively, wrapping the connection in an eval block allows for more graceful error handling, enabling you to catch exceptions and respond appropriately. Always ensure that your credentials are kept secure and not hard-coded in production environments. Once a connection is established, the next step is to execute SQL queries. The DBI module provides the prepare method to compile SQL statements, which helps prevent SQL injection and improves performance when executing the same query multiple times. For instance, preparing a select statement like select from users allows you to execute it later with the execute method. When working with dynamic values, such as user input, placeholders are essential. These placeholders, represented by question marks or named parameters, act as variables in the SQL statement. For example, insert into table call one values uses a placeholder for the value, which is then provided during execution. This approach ensures that data is safely inserted without risking malicious SQL code. After executing a query, retrieving the results is a critical step. The fetchArray method allows you to retrieve rows of data as an array, while fetchRef returns them as a hash reference, mapping column names to their values. This flexibility makes it easier to process data in different formats depending on your needs. When looping through results, you can use a while loop to iterate over each row, performing operations such as displaying data or processing it further. It is important to call the finish method on the statement handle after you are done to free up resources and avoid memory leaks. Properly managing these objects ensures that your application remains efficient and scalable. The DBI module offers a comprehensive set of methods to interact with databases, providing a unified interface across different database systems. Key methods include connect for establishing a connection, prepare for compiling queries, execute for running them, fetch for retrieving results, and do for executing non-select statements like insert, update, or delete. Additionally, DBI supports transactions, which are essential for maintaining data integrity. The begin work method starts a transaction, while commit finalizes it, and rollback undoes changes if an error occurs. These features are particularly useful when performing multiple related operations that must either all succeed or all fail. By leveraging these methods, you can build reliable applications that handle complex database interactions with ease. When working with databases in Perl, following best practices and prioritizing security is crucial. One of the most important practices is using placeholders in SQL queries to prevent SQL injection attacks. By separating SQL code from data, you ensure that user input cannot alter the intended behavior of the query. Always remember to close database connections using the disconnect method when they are no longer needed, as leaving them open can lead to resource exhaustion. Exception handling is another key aspect, and using eval or the try tiny module allows you to catch errors gracefully. Finally, storing database credentials securely, such as in environment variables or encrypted configuration files, protects sensitive information from being exposed in your code base. These steps collectively enhance the security and reliability of your applications. To illustrate the practical application of these concepts, let's walk through a simple database example. First, connect to a database using DBI Connect with the appropriate DSN, username, and password. Next, insert a record into a table by preparing an insert statement with a placeholder, then executing it with the desired values. For updating data, the do method is useful for non-select queries, such as changing a value in a specific row. Finally, retrieve and display data by preparing a select statement, executing it, and looping through the results using fetch or fetch-href. Each step should include error handling to ensure the application can respond to issues like invalid data or connection failures. This example demonstrates how to build a basic database-driven application in Perl. In conclusion, Perl's DBI module provides a powerful and flexible way to interact with databases, making it an invaluable tool for developers. By mastering SQL and the DBI interface, you can efficiently manage data across various database systems. However, it is equally important to follow security practices, such as using placeholders and securing credentials to protect against vulnerabilities. Applying these concepts in real-world scenarios will deepen your understanding and improve your ability to build robust applications. As you continue to practice, you will gain confidence in handling complex database operations and leveraging Perl's capabilities to their fullest. XML and JSON are two of the most widely used formats for exchanging data between systems. XML, which stands for Extensible Markup Language, uses a hierarchical structure of nested tags to represent data. This makes it highly structured and suitable for complex data models. JSON, or JavaScript Object Notation, is a lightweight format that uses key-value pairs, making it easier to read and write. Its simplicity has made it a popular choice for web APIs and modern applications. Perl, a versatile programming language, offers a range of modules to work with both formats. These tools allow developers to parse, generate, and manipulate XML and JSON data efficiently, making Perl a powerful option for data processing tasks. When working with XML in Perl, two key modules are commonly used. The first is XML Simple, which provides a straightforward way to parse and generate XML files. It is ideal for simple use cases where the XML structure is not too complex. However, for more advanced scenarios, XML, libxml is the preferred choice. This module offers robust features such as XPath support, allowing developers to query and navigate XML documents with precision. The functions xmlin and xmlout are central to these operations. xmlin converts XML data into a Perl data structure, while xmlout does the reverse, turning Perl data into XML. These functions enable tasks like loading XML files, extracting specific node values, and modifying data within the document. For JSON processing in Perl, the JSON XS module is the go-to option for speed and efficiency. It is written in C and provides a significant performance boost over other modules, making it ideal for applications where handling large volumes of data is critical. If compatibility is a concern, JSON PP serves as a pure Perl alternative, ensuring functionality even in environments where C modules might not be available. The core functions for JSON processing are encode-JSON and decode-JSON. Encode-JSON transforms Perl data structures, such as hashes and arrays, into JSON format, while decode-JSON performs the reverse. These functions are essential for tasks like serializing data for transmission over a network or storing it in a file. Parsing XML in Perl typically involves using the XML libxml module, which provides a comprehensive set of tools for working with XML documents. To load XML content, developers can use the XML libxml document new method or rely on XML simple for simpler tasks. Once the document is loaded, the find nodes or find methods allow traversal of the XML tree, enabling access to specific nodes based on their structure. Extracting text content from a node is straightforward with methods like text content or string value, which retrieve the inner text of an element. Additionally, attributes can be accessed using the attributes method, which returns a hash of the node's properties. This flexibility makes XML libxml a powerful tool for handling complex XML structures. Generating XML in Perl requires creating a document structure and building it step by step. Using the XML libxml document class, developers can start by creating a new document instance. Elements are then added using the createElement method, while text content is inserted with createText node. These elements are appended to the document tree, forming a hierarchical structure. Once the document is built, it can be serialized into a string using the AskSmol method, which outputs the XML data in a readable format. For example, a simple XML structure like a list of books can be constructed from a Perl hash, demonstrating how data can be transformed into a structured XML format programmatically. Parsing JSON in Perl is a common task, especially when dealing with data from web APIs. The decode-JSON function is used to convert a JSON string into a Perl data structure, such as a hash or array. This allows developers to work with the data in a familiar format. Handling nested JSON objects and arrays requires traversing the resulting data structure, which can be done using standard Perl operations. It is also crucial to validate JSON input to ensure it is correctly formatted and to avoid errors during processing. By incorporating validation checks, developers can handle malformed JSON gracefully, preventing crashes or unexpected behavior in their applications. Generating JSON in Perl involves converting Perl data structures into a JSON string using the encodejson function. This is particularly useful for sending data over a network or storing it in a file. The encodejson function offers options to customize the output, such as enabling pretty printing for human-readable formatting or allowing non-reference data. Special characters, such as Unicode or reserved JSON characters, are automatically handled to ensure the output is valid. For instance, a Perl hash containing user information can be serialized into a JSON string, which can then be transmitted to a client application. This process ensures that data remains consistent and interoperable across different systems. XML and JSON each have distinct use cases that make them suitable for different scenarios. XML is often used in legacy systems, configuration files, and environments where complex data hierarchies are required. Its ability to define schemas through DTDs or XSDs makes it a reliable choice for structured data exchange. JSON, on the other hand, is favored for web APIs, mobile applications, and modern software due to its simplicity and ease of use. When choosing between the two, consider the complexity of the data and the performance requirements. XML is better suited for intricate, hierarchical data, while JSON offers a lightweight and fast solution for most modern applications. Error handling and validation are critical when working with XML and JSON in Perl. For XML, the XML libxml module provides mechanisms to check for parsing errors, such as malformed tags or incorrect syntax. Additionally, XML documents can be validated against DTDs or XSDs to ensure they conform to a specified structure. In JSON processing, the JSON, XS module includes error detection features, and using eval blocks allows developers to catch exceptions during encoding or decoding. These practices help prevent crashes and ensure that data is processed reliably, even when encountering unexpected input. Implementing thorough error handling improves the robustness of applications that rely on XML or JSON data. Best practices for working with XML and JSON in Perl involve selecting the right tools for the task. For performance-critical applications, JSON XS is the preferred module due to its speed, while XML libxml is recommended for handling large XML files or complex queries. Avoid using XML, simple for advanced features, as it lacks the flexibility of XML. libxml. Input validation is also essential to prevent issues like injection attacks or data corruption. By following these guidelines, developers can ensure their code is efficient, maintainable, and secure. Regular practice with parsing, generating, and validating XML and JSON data will further enhance proficiency in these essential data formats. In conclusion, XML and JSON are indispensable tools for data interchange in Perl, each with its own strengths and use cases. Modules like XML, libxml, and JSON XS provide powerful capabilities for working with these formats, enabling developers to handle complex tasks efficiently. Choosing between XML and JSON depends on factors such as data complexity, performance needs, and application requirements. By mastering the techniques for parsing, generating, and validating XML and JSON data, Perl programmers can build robust and scalable solutions. Regular practice with these tools will solidify understanding and improve overall proficiency in working with structured data. Perl provides robust modules for network communication, making it a versatile tool for interacting with external systems, APIs, and services. These capabilities allow developers to build applications that can send and receive data across networks, enabling integration with web services, remote servers, and other devices. The key areas of focus include sockets, which are the foundational building blocks for network communication, as well as HTTP protocols for web interactions. Understanding TCP and UDP protocols is essential, as they define how data is transmitted reliably or quickly. Additionally, the client-server model underpins many networked applications where one system requests data and another provides it. By leveraging Perl's networking tools, developers can create dynamic, interconnected systems that respond to real-time data and user interactions. Several key Perl modules simplify network programming. The socket module offers low-level socket operations, giving developers direct control over network connections. Socket is a higher-level module that streamlines the creation of TCP and UDP sockets, reducing the complexity of writing network code. Telnet is designed for automating telnet sessions, which are often used to interact with legacy systems or remote devices. LWP, or the library for www in Perl, is essential for handling HTTP and HTTPS requests, allowing scripts to fetch web content, submit forms, or interact with REST-TFL APIs. Finally, NET SSH enables secure shell interactions, providing a way to execute commands on remote servers securely. These modules collectively empower Perl to handle a wide range of network tasks efficiently. Sockets serve as the fundamental endpoints for communication between systems. They act as virtual channels through which data flows, enabling processes to exchange information over a network. Two primary types of sockets exist: TCP and UDP. TCP, or Transmission Control Protocol, ensures reliable, connection-oriented communication. It guarantees that data arrives in the correct order and without errors, making it ideal for applications like web browsing or email. UDP, or User Datagram Protocol, prioritizes speed over reliability, offering a connectionless approach that is well suited for real-time applications such as video streaming or online gaming. Perl's socket module provides functions to create and configure these sockets, allowing developers to implement custom network protocols or interact with existing services. Creating a TCP server in Perl involves setting up a listening socket that waits for incoming connections. The process begins by initializing a socket that binds to a specific port, such as 8080, and listens for clients. Once a connection is established, the server accepts the incoming request and creates a new socket for communication. This allows the server to handle multiple clients simultaneously. Data is then exchanged through the connected socket, with the server reading input and sending responses as needed. For example, a simple server might listen on port 8080, accept a connection, and respond with a greeting message. This approach forms the basis of many networked applications, from chat servers to web services. A TCP client in Perl connects to a server to send and receive data. The client initializes a socket and specifies the server's IP address and port, such as 127.0.0.1 and 8080. Once the connection is established, the client can send data using functions like print or send, and receive responses by reading from the socket. For instance, a client might send a hello message to a server and then read the server's reply. This interaction is fundamental to many applications, such as command line tools that communicate with remote servers, or desktop applications that fetch data from a backend service. The simplicity of TCP ensures that the data is transmitted reliably, making it a popular choice for critical network interactions. UDP communication in Perl uses the EO socket UDP module to handle datagram-based interactions. Unlike TCP, UDP does not establish a connection before sending data, making it faster but less reliable. This makes UDP ideal for scenarios where speed is more important than guaranteed delivery, such as video conferencing or online gaming. To use UDP, a script creates a socket, binds it to a port, and then sends data using the send function. The recipient listens for incoming datagrams and processes them as they arrive. For example, a server might listen on port 5000, receive messages from clients, and respond with a confirmation. While UDP lacks the error checking of TCP, its efficiency makes it a valuable tool for specific use cases. HTTP requests in Perl are handled efficiently using the LWP module, specifically the LWP user agent class. This allows scripts to fetch web content, submit data to servers, and manage cookies or headers. For instance, a simple script might retrieve the content of a web page by calling the get method on a user agent object. More complex interactions, such as sending post data or setting custom headers, can be achieved by configuring the request object before sending it. LWP supports both HTTP and HTTPS, enabling secure communication with web services. This flexibility makes LWP a powerful tool for automating tasks like web scraping, API integration, or monitoring online resources. By leveraging these features, developers can build applications that interact seamlessly with the web. The Telnet module in Perl automates interactions with Telnet servers, which are often used to manage remote devices or legacy systems. By creating a Telnet object and specifying the host, users can establish a connection and send commands as if they were typing them manually. For example, a script might log into a router, execute a command like LSL, and capture the output for further processing. This is particularly useful for tasks such as configuring network equipment, retrieving system information, or automating repetitive administrative tasks. However, it is important to note that Telnet is not secure, as it transmits data in plain text. For secure interactions, alternatives like SSH are recommended, but Telnet remains valuable for specific use cases involving older systems. Advanced networking topics in Perl include asynchronous I/O, which allows programs to handle multiple tasks simultaneously without blocking. Modules like PoE or Caro enable non-blocking operations, making it easier to build high-performance servers that can manage many connections at once. Secure communication is another critical area, with modules like SSL providing support for SSL/TLS encryption. This ensures that data transmitted over the network remains confidential and tamper-proof. Additionally, integrating with REST APIs using Mojo User Agent allows Perl scripts to interact with modern web services, enabling features like authentication, data retrieval, and real-time updates. These advanced techniques expand Perl's capabilities, making it suitable for complex, secure, and scalable network applications. Best practices for Perl networking emphasize reliability, security, and maintainability, always handling errors with functions like die or warn ensures that scripts can respond gracefully to failures, preventing crashes or data loss. Using non-blocking I/O improves scalability, allowing a single process to manage multiple connections efficiently. Encrypting sensitive data, such as passwords or personal information, is crucial for protecting it from interception. Testing networked applications with tools like Netcat or curl helps verify that they behave as expected under various conditions. By following these practices, developers can create robust, secure, and efficient Perl programs that perform well in real-world scenarios. Perl offers powerful tools for networking tasks, making it an excellent choice for developers working on networked applications. From basic socket programming to advanced HTTP and SSH interactions, Perl's modules provide the flexibility needed to handle a wide range of scenarios. Mastering concepts like TCP/UDP, client-server models, and HTTP requests enables the creation of servers, clients, and automated systems that interact with external services. By applying these principles, developers can build scalable, secure, and efficient solutions that leverage Perl's strengths in network programming. Whether automating tasks, integrating with APIs, or building custom network protocols, Perl remains a versatile and effective language for networking challenges. Security is a fundamental aspect of building reliable and trustworthy applications, especially in today's digital landscape, where threats are constantly evolving. Perl, like any programming language, is not immune to vulnerabilities, and understanding security principles is crucial for developers. Common threats include injection attacks, where malicious data is inserted into code to execute unintended actions. Cross-site scripting that allows attackers to inject client-side scripts into web pages, and insecure data handling that can lead to data breaches. This session aims to equip you with the knowledge to identify these vulnerabilities and implement practical safeguards to protect Perl applications from potential exploits. Perl applications are susceptible to various security vulnerabilities that can compromise their integrity and confidentiality. Injection attacks, such as SQL injection or command injection, occur when untrusted data is used to manipulate the execution flow of an application. Improper input validation can lead to unexpected behavior or data corruption, while the insecure use of modules or libraries might introduce known vulnerabilities. Weak authentication and authorization mechanisms, such as using plain text passwords or insufficient role-based access controls, can allow unauthorized users to gain access to sensitive parts of an application. Recognizing these risks is the first step in building secure Perl code. Adopting secure coding practices is essential to mitigate risks in Perl applications. Always validate and sanitize user inputs to prevent malicious data from causing harm. Perl's taint mode, activated with the T flag, helps detect unsafe operations by marking data from external sources as tainted, forcing developers to explicitly untaint it before use. Avoid using the eval function with untrusted data, as it can execute arbitrary code and lead to security breaches. Additionally, limit the permissions of system calls and file operations to minimize the impact of potential vulnerabilities. These practices create a robust defense against common attack vectors. Leveraging well-maintained modules and libraries can significantly enhance the security of Perl applications. Modules like CGI and DBI provide standardized ways to handle web requests and database interactions, reducing the risk of implementation errors. The security insecure module, while perhaps a misnomer, highlights the importance of avoiding insecure practices by promoting safer alternatives. For encryption and hashing, prefer modules from the crypt namespace, such as crypt, AES for data encryption or crypt, password MD5 for secure password storage. Always ensure that dependencies are up to date and avoid using outdated or unmaintained libraries, as they may contain unresolved vulnerabilities. Secure data handling is critical to protecting sensitive information in Perl applications. Encrypting data using strong algorithms, such as those provided by the crypt AES module, ensures that even if data is intercepted, it remains unreadable. Storing credentials securely, such as through environment variables or encrypted files, prevents exposure in source code or configuration files. Additionally, always use HTTPS for network communication to encrypt data in transit and prevent eavesdropping. These measures create a layered defense to safeguard data from unauthorized access and tampering. Authentication and authorization mechanisms must be designed with security in mind to prevent unauthorized access. Use strong password hashing algorithms like bcrypt, available through the Authn passphrase module, to store passwords securely. Implement role-based access control (RBAC) to ensure users only have access to the resources they need. Avoid hard-coding credentials in source code, as this makes them vulnerable to exposure. Instead, use secure methods like configuration files with restricted permissions or external secret management systems. These practices ensure that only authorized users can perform specific actions within the application. Protecting Perl scripts against common attacks requires proactive measures. To prevent SQL injection, always use prepared statements with database modules like DBI, which separate SQL code from user input. Escape output data to prevent cross-site scripting by using modules like HTML entities, which converts special characters into safe representations. Control error reporting by using CGI, CARP, to log errors securely, and avoid exposing sensitive information to users. These techniques help mitigate the risk of malicious actors exploiting vulnerabilities in the application. Regular security audits and updates are vital to maintaining the integrity of Perl applications. Keep the Perl interpreter and all modules up to date by using tools like cPanum Self-Upgrade to ensure you have the latest security patches. Run static analysis tools such as Perl Critic to identify potential security issues in your code base. Monitor dependencies for known vulnerabilities using resources like the CPAN repository or third-party tools that track security advisories. By staying vigilant and proactive, you can address emerging threats before they become critical issues. In conclusion, security is not an afterthought, but a fundamental component of developing Perl applications. By following secure coding practices, using trusted modules, and staying informed about emerging threats, you can significantly reduce the risk of vulnerabilities. Regular updates, audits, and continuous education are essential to maintaining a secure environment. Remember, security is an ongoing process that requires attention, discipline, and a commitment to best practices to protect both your applications and their users. Consistent indentation is essential for code readability. Whether you choose 4 spaces or tabs, the key is to apply the same style throughout your code base. This helps readers quickly grasp the structure of your programs. Avoid overly complex one-liners by breaking them into multiple lines. For example, instead of a single line with nested functions, split it into steps that each perform a single task. Meaningful variable and subroutine names act as self-documenting code. Instead of using cryptic names like $X or temp, opt for descriptive terms like username or calculated total. Finally, Keep functions short and focused on a single responsibility. This makes your code easier to test, debug, and maintain. When naming variables, use lowercase letters with underscores to separate words, such as username. This convention improves readability and avoids confusion with other types of identifiers. Subroutines should also follow this pattern, like calculate total, to signal their purpose. Constants, which represent fixed values, should be in uppercase with underscores, such as maxritris, to distinguish them from variables. Modules, which are reusable Perl libraries, should have names that start with a capital letter, like data, dumper, to align with Perl's module naming standards. These conventions create a unified style that makes your code more approachable for others. Comments are valuable for explaining non-obvious logic or complex algorithms. For instance, if you implement a custom sorting routine, a comment can clarify why a particular comparison is used. However, avoid redundant comments that merely restate what the code does, like increment x for x plus dollars. Such comments add noise and can become outdated. Instead, use pod plain old documentation to write comprehensive documentation for modules, describing their purpose, parameters, and return values. Always update comments when you modify the code to ensure they remain accurate. This practice saves time for future developers who may need to understand or extend your work. When handling errors, use die or croak for fatal issues that prevent the program from continuing, such as failed file operations. These functions terminate the script and provide clear error messages. For non-fatal warnings, use warn or carp, which allow the program to proceed while alerting the user to potential problems. Always check the return values of functions like open or system to detect failures early. For example, if opening a file fails, handle the error gracefully instead of assuming it succeeded. Use eval to catch exceptions, which can help prevent crashes and enable recovery in critical sections of your code. Leverage Perl's core modules instead of writing custom code for common tasks. Modules like list, util, or file spec are well tested and reduce the risk of bugs. Always include useStrict and use warnings at the beginning of your scripts to enforce good practices and catch potential issues. Avoid global variables by using lexical variables declared with my, limit their scope and prevent unintended side effects. Finally, modularize your code by grouping related functionality into subroutines or modules. This promotes reusability and makes your code easier to manage as it grows. Writing test cases is crucial for ensuring your code works as intended. Use test, more or test. Simple to create tests that verify specific behaviors. For example, test edge cases like empty inputs or maximum values to uncover hidden bugs. Automate testing with tools like Prove or continuous integration systems to run tests regularly. Keep tests concise and focused on individual functions or modules to avoid confusion. A well-designed test suite acts as a safety net, allowing you to make changes with confidence while maintaining the integrity of your code. Peer reviews are an excellent way to catch issues early and improve code quality. When reviewing code, look for consistency in style, clarity of logic, and adherence to best practices. Follow your team's style guide, such as the Perl Best Practices PBP book, to maintain uniformity. Use tools like Perl Critic to analyze your code for potential problems and enforce standards. Finally, embrace feedback as a chance to refine your skills. Code reviews and criticism are not about perfection, but about continuous improvement and collaboration. Maintainability starts with consistent style and structure. Readability should always take precedence over brevity, as clear code is easier to understand and modify. Perl offers powerful tools and modules that can simplify complex tasks, so take advantage of them. Finally, remember that learning is an ongoing process. Stay curious, seek feedback, and keep refining your practices. By combining these principles, you'll write Perl code that is robust, efficient, and easy to work with over time. Refactoring is the process of improving code structure without changing functionality. This means that we can make the code easier to read, maintain, and understand, while ensuring that it still performs the same tasks as before. The main goals of refactoring are to enhance readability, which makes the code more accessible to others, improve maintainability, which reduces the effort needed to update or fix the code in the future, and boost performance, which can lead to faster execution. Common scenarios where refactoring is useful include duplicated code, which can lead to inconsistencies and errors if changes are not made in all copies, long functions that are difficult to manage and test, and unclear variable names that make the code harder to follow. By addressing these issues, we create a more robust and efficient code base. The benefits of refactoring are numerous and impactful. One key advantage is that it simplifies complex logic, making it easier to debug and understand. This is especially important in large projects where code can become tangled over time. Refactoring also reduces technical debt, which is the accumulated cost of taking shortcuts or making quick fixes that may require more work later. By addressing these issues early, we lower future maintenance costs. Additionally, refactoring improves code consistency across projects, ensuring that all parts of a code base follow similar patterns and conventions. This consistency makes it easier for developers to collaborate, as they can quickly understand and work with each other's code without needing to learn new styles or structures. There are several common refactoring techniques in Perl that can help improve code quality. One approach is to extract subroutines for repetitive code blocks, which reduces duplication and makes the code more modular. For example, if a set of lines appears in multiple places, wrapping them in a subroutine allows for easier reuse and maintenance. Another technique is to replace conditionals with dispatch tables or polymorphism, which can make the code cleaner and more scalable. For instance, instead of a long chain of if else statements, a hash can map values to functions, improving readability. Renaming variables and methods for clarity is also essential, as meaningful names make the code self-explanatory. Finally, eliminating dead code and redundant checks ensures that the code base remains lean and focused on its actual requirements. Several tools can aid in refactoring Perl code, making the process more efficient and reliable. Perl Critic is a powerful tool that enforces coding standards and identifies bad practices, helping developers adhere to best practices and avoid common pitfalls. Devel Cover analyzes test coverage, which is crucial for identifying untested code that may need attention during refactoring. Perl Tidy is useful for formatting code, ensuring that it follows a consistent style and is easier to read. Lastly, Test More is a testing framework that ensures refactoring does not break existing functionality by providing a suite of tests to verify the code's correctness. Together, these tools create a robust environment for safe and effective refactoring. To refactor effectively, it is important to follow best practices. Writing tests before refactoring is critical, as it provides a safety net to catch any unintended changes. Refactoring incrementally rather than making large-scale changes all at once helps manage complexity and reduces the risk of errors. Documenting changes is also essential, as it explains the purpose of modifications and helps others understand the code's evolution. Finally, using version control allows developers to track changes, revert to previous states if needed, and collaborate more efficiently. These practices ensure that refactoring is a controlled and beneficial process. Let me illustrate how refactoring can simplify conditionals. In the original code, a series of if else statements checks the value of a variable called type. For example, if the type is one block of code runs, and if it is B, another block runs. This approach can become unwieldy as more conditions are added, leading to a long and hard to maintain chain. By replacing this with a dispatch table, we can map each possible value of type to a corresponding function. This not only makes the code more concise, but also allows for easier expansion, as new entries can be added to the table without modifying the existing logic. The result is a more scalable and readable solution. Another common refactoring technique is extracting subroutines. Consider a function called process data that contains 100 lines of code. This makes the function difficult to understand, test, and maintain. By breaking it into smaller, focused subroutines, such as validate data, calculate metrics, and output results, each part of the process becomes clearer and more manageable. This modular approach allows for better testing of individual components and reduces the risk of errors when making changes. Additionally, it makes the code more reusable, as each subroutine can be called in different contexts. The overall result is a code base that is easier to navigate and maintain. While refactoring offers many benefits, there are common pitfalls to avoid. One critical mistake is refactoring without fully understanding the original code, which can lead to unintended consequences. It is important to take the time to analyze the code's purpose and behavior before making changes. Over-engineering is another risk, as adding unnecessary complexity can make the code harder to maintain. Simplicity should always be the goal. Removing comments without replacing them with documentation can also be problematic, as comments often provide valuable context. Finally, thorough testing after each change is essential to ensure that the code continues to function as intended. Refactoring can also focus on improving performance. For example, replacing slow loops with built-in functions like map or grep can significantly speed up execution, as these functions are optimized in Perl. Memization, which stores the results of expensive calculations for reuse, can prevent redundant work and improve efficiency. Minimizing the use of global variables and preferring lexical scoping helps reduce side effects and makes the code more predictable. Additionally, optimizing regular expressions by using efficient patterns and avoiding unnecessary backtracking can enhance performance. These techniques ensure that the code not only works correctly, but also runs as efficiently as possible. In conclusion, refactoring is a vital practice that improves code quality and developer productivity. By using tools and best practices, we can ensure that changes are made safely and effectively. Prioritizing readability and maintainability over quick fixes leads to a more sustainable code base. Continuous refactoring is essential for long-term project success, as it allows the code to evolve and adapt to new requirements without becoming a burden. Embracing refactoring as an ongoing process helps create a more robust, efficient, and collaborative development environment. Design patterns are like blueprints that provide solutions to recurring challenges in software development. They act as a shared language for developers, allowing us to build more efficient and maintainable code. In Perl, these patterns help structure programs in a way that is easier to understand, modify, and scale. For example, the singleton pattern ensures a class has only one instance, which is useful for managing resources like database connections. The factory pattern simplifies object creation, while the observer pattern enables communication between objects in a decoupled way. These patterns are not rigid rules, but proven strategies that can be adapted to fit specific needs. One of the key advantages of design patterns is their ability to make code more readable. When developers recognize a pattern, they can quickly grasp the intent behind the code. This improves maintainability, as changes can be made more predictably. Patterns also promote reuse, allowing solutions to be applied across different projects without reinventing the wheel. By leveraging these established approaches, teams can save time during development and reduce errors. Additionally, design patterns foster collaboration by providing a common framework for communication, ensuring everyone works toward a unified goal. Perl offers several design patterns that address common programming challenges. The singleton pattern ensures a single instance of a class, which is ideal for resources that should be shared across an application. The factory pattern centralizes the creation of objects, making it easier to manage dependencies and switch between different implementations. The observer pattern allows objects to notify others of changes, which is useful in event-driven systems. The decorator pattern adds behavior to objects dynamically, avoiding the need for complex inheritance hierarchies. Finally, the strategy pattern enables algorithms to be encapsulated and swapped at runtime, providing flexibility in problem solving. The singleton pattern is particularly useful when a single instance of a class must be shared across an application. In Perl, this is often achieved by making the constructor private and providing a static method to retrieve the instance. For example, a configuration manager might use singleton to ensure all parts of the program access the same configuration data. However, overusing singleton can lead to global state issues, making the code harder to test and maintain. It's important to use this pattern judiciously, reserving it for scenarios where a single, centralized resource is truly necessary. The factory pattern simplifies object creation by encapsulating the logic for generating instances. Instead of hard-coding class names in the code, a factory class or method can handle the creation process. This reduces dependencies between classes and makes the code more modular. For instance, a factory might create different types of data processors based on user input, such as CSV or JSON handlers. By centralizing this logic, changes to object creation can be made in one place, improving flexibility and reducing the risk of errors. Factories are especially valuable in applications where the type of object needed may vary dynamically. The observer pattern is ideal for scenarios where objects need to communicate without being tightly coupled. In this model, a subject maintains a list of observers and notifies them of state changes. For example, in a GUI application, a button click might trigger updates in multiple components. Perl can implement this using callbacks or method subscriptions, allowing observers to react to events without knowing the details of the subject. This pattern is widely used in logging systems, where changes in the application state are tracked and reported to various modules. It promotes loose coupling and makes the system more scalable. The decorator pattern allows developers to add functionality to objects dynamically without altering their structure. This is achieved by wrapping the object with a decorator that extends its behavior. For instance, a file handle could be enhanced with logging or compression features using a decorator. This approach avoids the complexity of subclassing and keeps the code base cleaner. In Perl, decorators can be implemented using closures or object composition, providing a flexible way to modify behavior at runtime. The key advantage is that it maintains the original object's interface while adding new capabilities, making it easier to manage evolving requirements. Design patterns find practical applications in real-world scenarios. A singleton might be used to manage a shared cache, ensuring all parts of an application access the same data. Factories can generate different report formats, such as PDF or HTML, based on user preferences. The observer pattern is useful for tracking user activity in web applications, where events like clicks or form submissions trigger updates. Decorators can enhance API requests by adding authentication or validation layers without modifying the original code. These examples illustrate how design patterns solve specific problems, making code more adaptable and maintainable. While design patterns are powerful tools, they are not a one-size-fits-all solution. Overusing them can introduce unnecessary complexity, making the code harder to understand. Some patterns may not fit certain scenarios, requiring developers to evaluate the problem carefully. Understanding the domain is crucial, as a pattern that works well in one context might fail in another. Balancing the use of patterns with simplicity is key to avoiding bloat. The goal is to apply patterns where they add clear value, rather than forcing them into every situation. This requires experience and a deep understanding of both the problem and the available solutions. In conclusion, design patterns are invaluable for improving code quality in Perl. They provide structured approaches to common challenges, enhancing readability, maintainability, and reusability. Choosing the right pattern depends on the specific needs of the project, so it's important to analyze the problem before applying a solution. Practicing these patterns in real-world scenarios helps solidify understanding and builds confidence in their application. As with any tool, continuous experimentation and refinement are essential to mastering design patterns and leveraging their full potential in software development. Functional programming is a programming paradigm that emphasizes writing code using pure functions, immutability, and higher-order functions. This approach focuses on avoiding side effects and making functions more predictable. Perl supports functional programming through features like code references, which allow functions to be treated as data, closures that capture their surrounding environment, and list comprehensions that enable concise data transformations. By adopting these techniques, developers can create more modular, testable, and maintainable code, reducing the likelihood of unexpected behavior caused by mutable state or global variables. A pure function is a function that produces the same output every time it is called with the same input and does not alter any external state. For example, a simple addition function like subadd returns $0 plus $1 will always return the same result for the same arguments. This predictability makes pure functions easier to test and debug. Avoiding global variables and mutable state ensures that functions do not interfere with each other, leading to cleaner and more reliable code. Immutability is the principle that once data is created, it should not be changed. In Perl, this can be achieved using functions like map, grep, and reduce, which transform data without modifying the original structure. For instance, the code myAtSquares equals map multiplied by @numbers creates a new list of squares without altering the original @numbers array. This approach prevents unintended side effects and makes it easier to reason about data flow in complex programs. Higher-order functions are functions that can take other functions as arguments or return them as results. Perl enables this through code references, which are essentially pointers to subroutines. For example, the function apply takes a code reference and an argument, then executes the function with that argument. This flexibility allows for powerful abstractions, such as creating generic functions that can be customized with different behaviors at runtime. Closures are functions that retain access to their lexical scope, even after the outer function has finished executing. This is useful for encapsulating state within a function. For instance, the counter function creates a lexical variable count that increments each time the returned anonymous function is called. Closures are particularly valuable for creating private variables and maintaining state in a controlled manner, which is essential for building modular and secure code. Recursion is a technique where a function calls itself to solve smaller instances of a problem. This is especially useful for tasks that can be broken down into similar subproblems, such as calculating factorials. The factorial function example demonstrates how recursion works by repeatedly calling itself with a reduced argument until it reaches a base case, which stops the recursion. Without a base case, the function would call itself indefinitely, leading to a stack overflow. Lazy evaluation is a strategy where computations are deferred until the result is actually needed. This can improve performance by avoiding unnecessary calculations. In Perl, while there is no built-in support for lazy evaluation, developers can simulate it using custom iterators or modules like list, util, reduce. For example, a lazy function might generate values on the fly instead of processing an entire dataset at once, which is particularly useful for handling large or infinite data streams. Perl offers several libraries that support functional programming practices. Modules like list, util provide functions such as reduce, which aggregates a list into a single value, and first, which finds the first element matching a condition. List, more utils, extends this with tools like grep and map, while scalar, util offers utilities for working with scalars. These libraries enable developers to write concise, expressive code that adheres to functional programming principles. To maximize the benefits of functional programming in Perl, prioritize writing pure functions that avoid side effects and focus on transforming input data. Embrace immutability by using functions like map and grep to create new data structures instead of modifying existing ones. Use closures to manage state in a controlled way and avoid global variables that can introduce unpredictability. By following these best practices, developers can create code that is easier to test, maintain, and scale. Functional programming techniques enhance code clarity and maintainability in Perl by promoting modular, predictable, and reusable code. Perl's flexibility allows developers to adopt these paradigms, even though it is not a purely functional language. By practicing the use of pure functions, immutability, and higher-order functions, programmers can write more robust and efficient solutions, encouraging a mindset that prioritizes testability and simplicity will help students and professionals alike leverage Perl's capabilities to their fullest. Metaprogramming is a powerful technique that allows programmers to write code that can manipulate or generate other code. This approach opens up possibilities for dynamic behavior, where programs can adapt and modify themselves during execution. It also enables the creation of code generation systems, which can automate repetitive tasks and provides a way to build higher-level abstractions that simplify complex operations. In the Perl programming language, metaprogramming is supported through several tools and features. For instance, the eval function allows strings of code to be executed as if they were part of the program itself. The begin block executes code at compile time, making it useful for initializing modules or setting up configurations before the rest of the program runs. Additionally, the B to parse module can analyze and deconstruct Perl code, offering insights into how the code is structured internally. The benefits of metaprogramming are significant. It offers flexibility by allowing developers to create more adaptable and reusable code. It reduces redundancy by automating the generation of repetitive code structures. Furthermore, it enables advanced abstractions, which can make complex systems more manageable and easier to maintain. Macros are a specific type of metaprogramming tool that allows developers to define code templates which are expanded at compile time rather than runtime. Unlike functions, which operate on values, macros work directly on the structure of the code itself. This distinction makes macros particularly useful for tasks that require modifying or generating code before it is executed. While Perl does not have a built-in macro system like some other languages, there are modules such as macro and moo that can simulate macro-like behavior. For example, the macro module allows developers to define macros using a specific syntax, which can then be expanded during the compilation phase. This can lead to more efficient code, as the macro expansion happens before the program runs. However, it is important to note that the syntax for macros in Perl is not as straightforward as in some other languages. The The example provided in the slide, which uses a hypothetical syntax like define MYMACRO, say hello, illustrates the concept, but is not an actual Perl construct. Instead, developers must rely on modules and creative use of Perl's existing features to achieve similar effects. Perl provides a variety of tools that facilitate metaprogramming, each serving a unique purpose. The eval function is one of the most well-known, allowing code to be executed dynamically from strings. This can be useful for tasks such as evaluating user input or generating code on the fly. However, it also comes with risks, such as potential security vulnerabilities, if not used carefully. The begin block is another essential tool, as it allows code to be executed during the compilation phase. This is particularly useful for initializing variables, loading modules, or performing setup tasks that need to be completed before the main program runs. The B, to parse module, is a powerful tool for analyzing Perl code. It can deconstruct code into its underlying structure, making it easier to understand how the code is interpreted by the Perl compiler. In addition to these, the Moose and Moo modules provide meta-object programming capabilities, allowing developers to manipulate classes and objects at runtime. Finally, the source filter module enables the modification of code before it is compiled, offering a way to pre-process or transform code in creative ways. Together, these tools give Perl developers a robust set of options for implementing metaprogramming techniques. Implementing macros in Perl can be achieved using the macro module, which is available on the comprehensive Perl archive network. To install the module, developers can use the cpan install macro command. Once installed, macros can be defined using the macro keyword, which allows for the creation of reusable code templates. For example, a macro named log could be defined to automatically print a message with a specific format. The code for such a macro might look like macro log open curly brace, say log :# msg close curly brace. This macro would then be expanded at compile time, replacing instances of log with the corresponding code. The advantage of this approach is that macros can be expanded before the program runs, eliminating the overhead associated with function calls. This can lead to performance improvements, especially in scenarios where the macro is used frequently. However, it is important to use macros judiciously, as they can complicate the code and make it harder to debug if overused. Metaprogramming has several practical use cases that make it a valuable tool for Perl developers. One of the most common applications is the creation of domain-specific languages, or DSLs. DSLs allow developers to define custom syntax tailored to a specific problem domain, making the code more readable and expressive. For example, a DSL for financial calculations could provide a set of operators and functions that simplify complex financial formulas. Another use case is code generation, where repetitive or boilerplate code is automatically generated. This can save time and reduce errors, as the generated code is consistent and follows predefined patterns. Metaprogramming is also useful for debugging, as it allows developers to insert logging or tracing mechanisms dynamically. For instance, a macro could be used to automatically log the entry and exit of functions, helping to identify issues without modifying the original code. Finally, metaprogramming can be used for optimization, where code is modified or transformed at compile time to improve performance. This might involve inlining functions, removing redundant operations, or restructuring code for better efficiency. While metaprogramming offers many benefits, it also presents several challenges that developers must be aware of. One of the primary challenges is complexity. Overuse of metaprogramming techniques can make code difficult to understand and maintain, as the logic may be hidden behind abstractions or macros. This can lead to a situation where the code is harder to debug, as the expanded code may differ significantly from the original source. Another challenge is the difficulty of debugging metaprogrammed code. When macros or other metaprogramming constructs are used, the actual code that runs may not match the source code, making it harder to trace the flow of execution. Additionally, the use of eval can introduce security risks, as it allows the execution of arbitrary code, which could be exploited if not properly controlled. To mitigate these challenges, it is essential to follow best practices. Developers should use metaprogramming sparingly, and only when it provides a clear benefit. When doing so, they should ensure that the abstractions are well documented and easy to understand. By focusing on clarity and maintainability, developers can harness the power of metaprogramming while minimizing its potential drawbacks. In conclusion, metaprogramming is a powerful technique that that empowers Perl developers to create more flexible, efficient, and maintainable code. By enabling the manipulation and generation of code at runtime or compile time, metaprogramming allows for the creation of advanced abstractions and custom tools. Macros, in particular, provide a way to expand code templates at compile time, offering performance benefits and reducing runtime overhead. Perl's ecosystem includes several tools that support metaprogramming, such as the macro module, deparse, and others, which provide developers with the flexibility to implement these techniques. However, it is crucial to use these tools responsibly. The key to successful metaprogramming lies in striking a balance between leveraging its capabilities and maintaining the clarity and maintainability of the code. By prioritizing well-documented abstractions and avoiding overuse, developers can fully harness the potential of metaprogramming while ensuring that their code remains readable and manageable. Testing is a critical component of any software development process, and in Perl, it plays a vital role in ensuring that your code functions as intended. By implementing tests, you can verify that your programs are reliable and correct, which is essential for maintaining high-quality code. Perl offers both built-in and third-party testing frameworks, giving developers flexibility in how they approach testing. Among these, the test more module stands out as the most widely used and powerful tool for writing tests. It provides a simple yet comprehensive set of functions that make it easy to create and manage test cases. Beyond just catching errors, testing helps identify bugs early in the development cycle, which saves time and effort. Additionally, it gives developers the confidence to refactor code without fear of introducing new issues, making the overall development process more efficient and robust. At the heart of Perl testing lies the test more module, which is part of the larger test harness suite. This suite is designed to streamline the testing process by providing tools for writing, running, and reporting on tests. Test more itself offers a variety of functions that make it straightforward to create test cases. These functions simplify the process of setting up a test plan and performing assertion checks, which are the building blocks of any testing framework. Whether you need to write basic tests that check for simple conditions or more complex scenarios that involve multiple steps, Test more is equipped to handle them. Its versatility makes it an essential tool for both beginners and experienced Perl developers who want to ensure their code is thoroughly tested. To begin using test more, you first need to import its functions into your script with the line use test more. Once imported, you can leverage several key functions to write your tests. The OK function is used for Boolean checks, allowing you to verify that a condition is true or false. For example, OK $condition. Description will pass if the condition evaluates to true. The is function is designed for checking equality, making it ideal for comparing values. The like function, on the other hand, is used for pattern matching, enabling you to test if a string matches a specific regular expression. These functions form the foundation of test more and are essential for creating effective and readable test cases. Let me walk through an example of a simple test script to illustrate how test more works. The script begins with use test more to import the necessary functions. Next, the plan tests equals 3 line sets the number of tests that will be run, ensuring that the test harness knows exactly how many tests to expect. The first test, OK 1 plus 1 equals 2, addition works, checks if the sum of 1 and 1 is indeed 2. The second test is 2 multiplied by 3, 6. Multiplication works, verifies that the product of 2 and 3 is 6. Finally, the third test, like Perl, qr/regex match checks if the string Perl contains the pattern This example demonstrates how test more can be used to create concise and informative tests that cover a range of scenarios. When writing tests, it's important to consider how to structure the test plan. A fixed test plan, such as plan tests equals 5, is useful when you know the exact number of tests in advance. However, in some cases, you may need a dynamic plan, which can be set using plan skip all equals, not supported on this OS. To skip all tests if certain conditions are not met. The skip function allows you to bypass specific tests when they are not applicable, while the to-do function is used to mark tests that are expected to fail, but are not yet fixed. Additionally, the don't-testing function provides flexibility by allowing you to run tests without specifying the total count up front. These features make test more adaptable to a wide range of testing scenarios. Test more also includes advanced features that enhance the testing process. One such feature is subtest, which allows you to group related tests together, making your test scripts more organized and easier to read. The diag function is used to print diagnostic messages, which can be helpful for debugging by providing additional information about test failures. The note function, on the other hand, is used to add non-fatal notes that do not affect the test outcome, but can still provide useful context. Finally, the istdply function is designed to compare complex data structures, such as arrays or hashes, ensuring that their contents match exactly. These advanced features make test more a powerful tool for handling intricate testing requirements, while test more is a powerful module. There are other testing tools in the Perl ecosystem that serve different purposes. Test Simple is a lighter alternative that provides the most basic testing functions, making it ideal for simple projects. Test Harness is a companion module that runs test scripts and generates detailed reports, helping developers understand the results of their tests. Test Expect is used for testing interactive programs, such as those that require user input or respond to external events. Lastly, Test Mock Object allows developers to simulate the behavior of objects, making it easier to test code that relies on external dependencies. Each of these modules has its own strengths and can be used in conjunction with test more to create a comprehensive testing strategy. To ensure effective testing in Perl, there are several best practices that every developer should follow. First, it's important to write tests for all edge cases, as these are often the source of unexpected behavior. Keeping tests independent and repeatable ensures that each test can be run in isolation without relying on the outcome of others, which improves reliability. Using descriptive test names helps other developers understand the purpose of each test at a glance. Finally, automating tests within continuous integration and delivery pipelines ensures that your code is consistently validated as it evolves. By following these practices, you can create a robust testing framework that enhances the quality and maintainability of your Perl applications. In conclusion, testing frameworks like Test More are indispensable tools for Perl developers, as they significantly improve code quality and maintainability. By integrating testing into your development workflow, you can catch errors early, refactor with confidence, and build more reliable applications. Regular practice in writing tests is essential for mastering this skill, and exploring additional modules can further expand your testing capabilities. Whether you're working on small scripts or large-scale applications, a strong testing strategy will always be a valuable asset. As you continue to develop your Perl skills, remember that testing is not just a step in the process, but a fundamental part of creating high-quality software. Continuous integration is a development practice where developers frequently merge their code changes into a central repository. This process is supported by automated tools that verify each integration through testing. The primary goal of continuous integration is to detect issues early, ensuring that the code base remains stable and functional at all times. By implementing continuous integration, teams benefit from early bug detection, which reduces the time and effort required to fix issues later in the development cycle. Faster feedback loops allow developers to identify and resolve problems quickly, improving overall productivity. Streamlined deployments become possible as the integration process ensures that the code is always in a deployable state. Key components of continuous integration include version control systems like Git, which track changes to the code base, automated testing frameworks that execute tests on every code change, and build automation tools that compile and package the application. These elements work together to create a reliable and efficient development workflow. Testing is essential for ensuring the reliability and correctness of Perl code. Perl is a flexible language that allows for multiple approaches to solving problems, but without thorough testing, it is easy to introduce errors that may be difficult to trace. Testing in Perl involves different types of tests, each serving a specific purpose. Unit tests focus on individual functions or modules, verifying that they behave as expected in isolation. Integration tests check how different parts of the application interact, ensuring that the components work together correctly. Regression tests are crucial for maintaining existing functionality, as they confirm that new changes do not break previously working features. Perl offers several testing tools that simplify the testing process. Test Simple provides basic testing functions, while Test More extends this with more advanced features like assertions and test planning. Test Harness manages the execution of test scripts, and the prove command allows developers to run tests from the command line. These tools collectively enable developers to build robust and maintainable Perl applications. When working with Perl projects, choosing the right continuous integration tool is critical. Popular platforms include Jenkins, which is highly customizable and supports a wide range of plugins for Perl development. Travis CI is another option, offering seamless integration with GitHub repositories and a straightforward configuration process. GitHub Actions and GitLab CI are also widely used, providing built-in support for automation workflows. Integrating Perl projects into these platforms involves configuring build scripts that handle dependencies, compile the code, and execute tests. Setting up test environments ensures that the code runs consistently across different systems, avoiding issues caused by varying configurations. For example, using Travis CI for a Perl module involves creating a configuration file that specifies the Perl version, installs required dependencies, and runs the test suite. This automation ensures that every code change is validated quickly, reducing the risk of introducing errors into the code base. Automating test execution is a fundamental step in establishing a reliable development process. The first step is to write test scripts using Perl's testing modules, such as test, more, which provides functions for writing detailed and expressive tests. These scripts should cover various aspects of the code, from individual functions to broader system interactions. Once the tests are written, they need to be integrated into the continuous integration pipeline. This integration ensures that every code change triggers an automatic test run, providing immediate feedback on the code's quality. Monitoring test results and failures is equally important. Developers should review test outputs to identify issues and address them promptly. Tools like Jenkins or Travis CI provide dashboards that display test results, making it easy to track the health of the project. By automating these steps, teams can maintain high code quality while reducing the manual effort required for testing. Adhering to best practices for continuous integration and testing ensures that the development process remains efficient and effective. One key practice is to keep tests fast and isolated, minimizing the time required to run the test suite and reducing the likelihood of test failures caused by external factors. Version control should be used for all test scripts, ensuring that changes to the tests are tracked and can be rolled back if necessary. Regularly updating dependencies and test environments is crucial for maintaining compatibility with the latest Perl versions and third-party modules. This practice also helps prevent security vulnerabilities and ensures that the code base remains up to date. Implementing code coverage analysis provides insights into which parts of the code are well tested and which may need additional tests. Tools like Devel Cover can measure coverage and highlight areas that require attention. By following these practices, teams can build a robust testing strategy that supports long-term project success. Continuous integration and testing are vital for developing reliable and maintainable Perl applications. By automating the integration and testing processes, teams can catch errors early, reduce manual effort, and ensure that the code base remains stable throughout the development lifecycle. Automation not only improves efficiency, but also minimizes the risk of human error, allowing developers to focus on writing high-quality code. Combining continuous integration tools with comprehensive testing strategies creates a powerful workflow that enhances productivity and code quality. Whether using Jenkins, Travis CI, or other platforms, the key is to establish a consistent and reliable process that supports the project's goals. By prioritizing testing and automation, Perl developers can build applications that are both robust and scalable, adapting to changing requirements with confidence. Deployment strategies are the methods and processes used to release software updates into production environments. They play a critical role in the software lifecycle by ensuring that changes are implemented smoothly with minimal disruption to users. For Perl applications, consistency, scalability, and reliability are essential because they handle complex data processing and require stable execution environments. Without well-defined strategies, even minor updates can lead to errors or downtime. Common deployment approaches include blue-green deployments, which use two identical environments to switch traffic between versions. Canary releases that test changes on a small subset of users before full rollout, and rolling updates that gradually replace instances of an application. Each method has its advantages, and the choice depends on the application's requirements and the team's workflow. Version control is a fundamental practice for managing code changes and deployment history. is the most widely used tool for this purpose, allowing developers to track every modification to the code base. Branching strategies such as feature branches, release branches, and trunk-based development help organize work. Feature branches isolate new functionality. Release branches prepare for a new version, and trunk-based development keeps the main branch stable with frequent integrations. Tagging releases is another critical practice, as it creates a permanent reference point for specific versions of the code. This makes it easier to trace changes, roll back to previous states, and ensure accountability during deployments. Continuous integration and deployment, or CI/CD, automate the process of testing and deploying code changes. Tools like Jenkins or GitHub Actions streamline this workflow by executing tests, building artifacts, and deploying to environments. For Perl applications, integrating modules and dependencies into CI/CD pipelines ensures that all required libraries are available and compatible. Validating deployments through automated tests and linters helps catch errors early, reducing the risk of failures in production. This approach not only speeds up the release cycle, but also improves code quality by enforcing best practices and catching issues before they reach end users. Environment management involves creating distinct setups for development, staging, and production to avoid conflicts and ensure stability. Development environments are for testing new features. Staging mirrors production for final validation, and production is the live system. Using Docker or virtual machines ensures that all environments are consistent, eliminating the "it works on my machine" problem. Configuration management tools like Ansible or Puppet automate the setup and maintenance of these environments, reducing manual errors. By standardizing environments, teams can focus on building features rather than troubleshooting deployment inconsistencies. Real-time monitoring is essential for maintaining the health of Perl applications. Tools like Nagios or Prometheus track metrics, such as response time, error rates, and resource usage, providing insights into performance. Logging errors and metrics with Perl modules like Log4Perl helps diagnose issues and understand user behavior. Setting up alerts for critical failures or anomalies ensures that teams can respond quickly to problems. For example, if a Perl script starts consuming excessive memory, an alert can trigger trigger a restart or investigation. Effective monitoring and logging transform reactive troubleshooting into proactive maintenance. Rollback strategies are plans to revert to a previous version of an application if a deployment fails. Versioned deployments, where each change is tracked and labeled, make rollbacks straightforward. Automating this process with scripts or CI/CD tools ensures that rollbacks are fast and reliable. Testing rollback procedures regularly is crucial because untested plans can fail under pressure. For instance, if a new Perl module introduces a bug, a well-documented rollback can restore the previous version within minutes. This reduces downtime and maintains user trust. Security is a cornerstone of deployment practices. Securing Perl code involves keeping dependencies up to date and using tools like cPanum or Carton to manage module versions. Sensitive data, such as API keys, should never be hard-coded, but instead stored in environment variables or secure vaults. Server hardening measures, such as restricting access permissions and disabling unnecessary services, minimize attack surfaces. For example, a Perl application running on a server should only have access to the specific directories it needs. These steps protect the application from vulnerabilities and ensure compliance with security standards. Documentation and communication are vital for successful deployments. Maintaining deployment guides and checklists ensures that all team members follow consistent procedures. Communicating changes to stakeholders, such as developers, testers, and operations, prevents misunderstandings and aligns expectations. Post-deployment reviews help identify what worked well and what needs improvement, fostering a culture of continuous learning. For example, after a Perl application update, a team might document lessons learned about testing strategies or deployment timing. This practice strengthens collaboration and reduces the likelihood of repeating mistakes. Deployment strategies are essential for ensuring that Perl applications are stable, scalable, and reliable. Automation, testing, and documentation form the foundation of efficient deployment workflows. By integrating these practices, teams can reduce risks, minimize downtime, and focus on innovation. Applying these strategies consistently across projects streamlines operations and builds confidence in the software delivery process. Whether using blue-green deployments or CI/CD pipelines, the goal remains the same: to deliver high-quality Perl applications with confidence and precision. Cloud computing involves delivering computing services such as servers, storage, and databases over the internet. This model allows organizations to access resources on demand without the need for physical infrastructure. The key models include infrastructure as a service, which provides virtualized computing resources; platform as a service, which offers a platform for developing and deploying applications; and software as a service, which delivers software applications directly over the internet. The benefits of cloud computing are numerous. Scalability enables businesses to easily adjust resources based on needs. Cost efficiency reduces the need for upfront investments in hardware. Flexibility allows for remote access and collaboration, and global accessibility ensures services can be delivered to users anywhere in the world. Perl excels in text processing, automation, and scripting, making it a powerful tool for cloud operations. Its ability to handle complex text manipulation and regular expressions is particularly useful for tasks like log file analysis and data extraction. Perl is widely used for interacting with APIs, which are essential for integrating cloud services. For example, scripts written in Perl can automate the creation of cloud resources or manage data transfers. DevOps tasks such as configuration management and deployment pipelines often rely on Perl for its scripting capabilities. Specific modules like Net, Amazon, S3, and Oz. S3 provide direct integration with cloud storage services, enabling developers to interact with platforms like Amazon S3 seamlessly. Cloud deployment strategies for Perl include containerization, which ensures consistent environments across development and production. Tools like Docker allow Perl applications to be packaged with their dependencies, eliminating the "it works on my machine" problem. Serverless architectures, such as AWS Lambda, leverage Perl for event-driven tasks. For instance, a Perl script can be triggered by a file upload to a cloud storage bucket, processing the data without the need for a dedicated server. Infrastructure as code tools like Terraform help manage cloud resources through code, enabling automated provisioning and updates. This approach enhances reproducibility and reduces manual errors in cloud infrastructure management. Cloud platforms such as AWS, Google Cloud, and Microsoft Azure support Perl through their SDKs, allowing developers to interact with cloud services programmatically. These platforms provide APIs for tasks like managing virtual machines, storage, and networking. DevOps tools like Ansible, Puppet, and Jenkins can automate Perl scripts for continuous integration and deployment workflows. For example, Jenkins can trigger a Perl script to test and deploy a cloud application. Monitoring tools like Prometheus and Grafana track metrics for cloud-based Perl applications, providing insights into performance and resource usage. This ensures that applications running in the cloud are both efficient and reliable. Best practices for Perl in the cloud emphasize modular code design, which improves scalability and reusability. Breaking scripts into functions or modules allows for easier maintenance and adaptation to changing requirements. Version control systems like Git are essential for tracking changes to Perl scripts deployed in the cloud, enabling collaboration and rollback capabilities. Secure cloud configurations require careful handling of API keys, IAM roles, and encryption. For example, sensitive data should be encrypted at rest and in transit, while IAM roles limit access to only necessary resources. These practices ensure that Perl applications in the cloud are both secure and maintainable. One challenge in cloud Perl environments is dependency management within containerized setups. Containers may include multiple Perl modules, and conflicts can arise. Tools like cPanum and Carton help isolate dependencies, ensuring the correct versions are used. For performance optimization, Perl's strength in I/O-bound tasks, such as processing large data sets or handling network requests, makes it well suited for cloud workloads. Developers can further enhance performance by leveraging Perl's built-in features like threads or asynchronous programming. Addressing these challenges ensures that Perl applications run efficiently and reliably in cloud environments. Perl remains relevant in cloud environments due to its flexibility and scripting strengths. Its ability to handle text, automate tasks, and integrate with cloud services makes it a valuable tool for modern IT. By combining Perl with cloud tools organizations can achieve greater automation, scalability, and deployment efficiency. For example, a Perl script can automate the setup of cloud infrastructure, reducing manual effort, continuous learning, and adaptation to cloud trends, such as adopting new DevOps practices or leveraging emerging cloud technologies. Ensure that Perl continues to play a vital role in the evolving IT landscape. DevOps is a set of practices that combines software development and IT operations to shorten the system development lifecycle while delivering features, fixes, and updates frequently. Its core principles include collaboration between teams, automation of repetitive tasks, and continuous delivery of reliable software. Perl has long been a valuable tool in this space due to its flexibility and powerful text processing capabilities. From automating system administration tasks to integrating with complex workflows, Perl scripts can handle everything from file manipulation to process control. In this session, we will explore how to automate tasks using Perl, integrate it into continuous integration and continuous delivery pipelines, and improve deployment efficiency through script-driven solutions. Perl excels at scripting system administration tasks, making it a go-to language for DevOps engineers. Whether you need to manipulate files, manage processes, or interact with system resources, Perl provides built-in functions and modules to simplify these operations. For example, you can use Perl to automate log rotation by scanning log files, compressing old entries, and archiving them. CPAN, the Comprehensive Perl Archive Network, offers a vast collection of modules that extend Perl's capabilities. Modules like net, SSH allow you to execute remote commands securely, while file, copy helps manage file transfers. By leveraging these tools, you can create robust scripts that streamline tasks such as configuration management, where Perl can dynamically update settings across multiple servers. Integrating Perl scripts into CI/CD pipelines is a powerful way to ensure consistent and reliable software delivery. Tools like Jenkins, GitLab CI, and GitHub Actions support scripting languages, and Perl can be embedded into these workflows to perform critical tasks. For instance, you can write Perl scripts to run unit tests as part of a pipeline stage, using modules like test more to verify code functionality. Test harness then aggregates results, providing clear feedback on test outcomes. This integration allows teams to catch issues early, ensuring that only well-tested code reaches production. By automating testing with Perl, you reduce manual intervention and increase the speed of deployment cycles. Monitoring and logging are essential for maintaining system health, and Perl provides tools to handle these tasks effectively. Real-time monitoring can track system metrics such as CPU usage, memory utilization, or network traffic. Perl scripts can also parse application logs to detect anomalies or errors. For example, a script might monitor server logs and send alerts via email or a messaging service when specific patterns appear. Tools like Nagios plugins and Prometheus exporters often use Perl to collect and report metrics. By writing custom Perl scripts, you can tailor monitoring solutions to your specific needs, ensuring proactive identification of potential issues before they escalate. Several Perl modules are specifically designed for DevOps tasks, making complex operations more manageable. IPC Run is useful for controlling external processes, allowing you to execute commands and capture their output. JSON Access provides efficient data serialization, which is crucial for interacting with APIs or configuration files. NetSSH enables secure remote execution of commands across different platforms, simplifying tasks like deploying updates or checking server status. Log4Perl offers a flexible logging system, allowing you to record events at various levels, such as debug, info, or error. These modules, along with others in CPAN, empower DevOps professionals to build scalable and maintainable automation solutions. Adhering to best practices ensures that Perl scripts are reliable, maintainable, and secure. Writing modular code, where functions and classes are separated by purpose, makes it easier to reuse and update scripts. Version control systems like Git should be used to track changes to scripts and configurations, enabling collaboration and rollback if needed. Documenting scripts with clear comments and usage instructions helps others understand and modify them. Security is also critical. Avoid hard-coding secrets like passwords or API keys. Instead, use environment variables or encrypted configuration files. Finally, automate testing with Perl's testing frameworks to catch errors early, ensuring that scripts perform as expected in production environments. Perl remains a powerful and versatile tool for DevOps, offering capabilities that span automation, CI/CD integration, and monitoring. Its extensive module library, CPAN, provides ready-made solutions for almost any task, reducing development time and effort. By following collaborative practices, prioritizing testing, and continuously refining workflows, teams can achieve more efficient and reliable software delivery. Whether you are automating routine tasks or building complex pipelines, Perl's flexibility and community support make it an invaluable asset in the DevOps toolkit. Embracing these principles will help you unlock the full potential of Perl in your DevOps journey. Automation scripts are powerful tools that streamline repetitive tasks, allowing users to focus on more complex challenges. By automating routines, we minimize the risk of human error, which is especially critical in environments where precision is essential. These scripts are widely used for tasks such as managing files, processing data, and monitoring systems. Perl, with its versatile syntax and extensive libraries, is particularly well suited for automation because it can handle a wide range of tasks efficiently across different platforms. Perl stands out as a premier choice for automation due to its robust text processing capabilities. Whether you need to parse log files or manipulate large datasets, Perl's built-in regular expressions and string functions make these tasks straightforward. Its cross-platform compatibility ensures that scripts written on one system can often run on another with minimal adjustments. Additionally, Perl's rich library ecosystem, including modules like file, copy for moving files or sys, hostname for retrieving system information, provides ready-made solutions for common automation needs. Integration with system commands is also seamless, allowing scripts to interact with the operating system and external tools effortlessly. A well-designed automation script relies on several key components. First, input handling is crucial, as scripts must gather data from sources like command line arguments, files, or user interactions. Next, the logic for task execution must be clear, often involving loops to repeat actions and conditionals to make decisions based on specific criteria. Output handling ensures that results are properly recorded or displayed, whether through logging, file writing, or system feedback. Finally, error handling and exception management are essential to anticipate and address issues. Preventing scripts from failing silently or causing unintended consequences. To write a basic automation script in Perl, start by using the @argv array to access command line arguments, which allows users to pass parameters directly when running the script. For file input and output, the open function is fundamental, enabling reading from or writing to files with ease. Regular expressions are invaluable for text manipulation, allowing you to search, replace, or extract specific patterns within data. For example, a script to rename files in a directory might iterate through all files, apply a regex to modify their names, and use the rename function to implement the changes. This simplicity makes Perl an excellent starting point for automation tasks. Advanced Perl automation techniques unlock even greater possibilities. The file find module is particularly useful for recursively searching through directories, making it ideal for tasks like finding specific files or processing all files in a tree structure. The eval function allows for dynamic code execution, which can be handy when generating or modifying scripts on the fly. Using system or backticks lets Perl interact with the operating system, executing shell commands and capturing their output. Finally, scheduling tasks with cron on Unix-like systems or Win32 Task Scheduler on Windows ensures that scripts run automatically at specified times, further reducing manual intervention. Real-world automation examples demonstrate Perl's practical value. For instance, analyzing log files can involve parsing through thousands of entries to identify errors or trends, which is efficiently handled by Perl's text processing features. Batch renaming files with regular expressions allows users to quickly standardize file names across large collections. Generating reports from CSV data might involve reading the file, processing the information, and outputting structured results. Monitoring system resources like CPU usage or memory can be automated using Perl to collect metrics and alert administrators when thresholds are exceeded, ensuring proactive system management. Adhering to best practices ensures that automation scripts are reliable and maintainable. Keeping scripts modular by breaking them into reusable functions or subroutines promotes code efficiency and clarity. Adding comments and documentation helps others understand the script's purpose and functionality, especially when collaborating or revisiting the code later. Thorough testing in controlled environments is essential to catch bugs before deployment. Finally, using version control systems like Git allows teams to track changes, revert to previous versions, and manage script development effectively over time. In conclusion, automation scripts are a cornerstone of modern efficiency, transforming tedious tasks into automated processes that save time and reduce errors. Perl's unique features, from its powerful text manipulation to its cross-platform flexibility, make it a formidable tool for automation. By practicing the creation of scripts for real-world scenarios, learners can build practical skills that enhance productivity. As automation workflows evolve, continuous refinement and optimization will ensure that scripts remain effective, adaptable, and aligned with changing requirements. Perl remains a powerful tool for system administrators due to its adaptability and extensive library support. Today, we will explore advanced techniques that elevate Perl beyond basic scripting. These methods are essential for automating complex tasks such as monitoring system performance, writing efficient scripts, and implementing robust security measures. Perl's strength lies in its ability to handle text, process files, and interact with the operating system, making it ideal for sysadmin workflows. By leveraging Perl's modules, we can streamline tasks that would otherwise require multiple tools or custom code. This presentation will guide you through the most effective ways to harness Perl's capabilities for system management. Several Perl modules are indispensable for system administration. Find simplifies recursive directory traversal, allowing scripts to search for files or apply operations across entire directory structures. Open3 provides a way to execute system commands and manage their input, output, and error streams, enabling bidirectional communication with external processes. Syslog facilitates integration with syslog daemons, ensuring consistent and centralized logging across systems. Getopt long enhances command line argument parsing, making it easier to handle complex options and parameters in scripts. Together, these modules form a foundation for building reliable and efficient system administration tools. Automating system tasks with Perl can significantly reduce manual effort and minimize errors. For instance, scripts can dynamically manage cron jobs by reading, modifying, or adding entries to the cron tab file. User account creation and deletion can be automated using system calls, and Perl's ability to interact with user management utilities. Backup and restore routines benefit from Perl's file system operations, such as copying, moving, or compressing files. By writing scripts that handle these tasks, administrators can ensure consistency and save time, especially when dealing with repetitive or large-scale operations. Advanced file and directory handling in Perl involves more than basic operations. Scripts can manipulate symbolic links, adjust file permissions, and modify ownership using functions like symlink, chmod, and chown. Recursive directory processing with file. Find allows scripts to perform actions on every file or subdirectory, such as searching for specific patterns or applying batch renaming. Efficient file searching can be achieved using regular expressions and file attributes, while batch renaming leverages Perl's string manipulation capabilities to automate naming conventions across multiple files. These techniques are crucial for maintaining organized and scalable system environments. Interacting with system commands is a common requirement in system administration. The system function and backticks allow scripts to execute commands and capture their output, but they have limitations in handling complex interactions. IPC Open3 offers a more robust solution, enabling bidirectional communication with processes and providing greater control over input and output. This is particularly useful for tasks like monitoring real-time processes or parsing structured data from command outputs. By mastering these methods, administrators can create scripts that respond dynamically to system events and integrate seamlessly with other tools. Monitoring and logging are critical for maintaining system health and security. Perl scripts can monitor log files in real time using tools like tailf or Notify, allowing for immediate detection of anomalies. Centralized logging via syslog ensures that logs are stored in a consistent format, making it easier to analyze and troubleshoot issues. Scripts can also implement alerting mechanisms, such as sending notifications when specific patterns are detected in logs. These capabilities enable administrators to proactively effectively address problems and maintain system stability. Security is a top priority when writing Perl scripts for system administration. Enabling taint mode ensures that external inputs are treated as untrusted, preventing potential injection attacks. Validating and sanitizing user inputs, such as command line arguments or file paths, reduces the risk of malicious activity. Sensitive data, like passwords, should be handled with care, using secure methods such as encryption or environment variables. By incorporating these practices, scripts can protect systems from vulnerabilities while maintaining functionality. Adopting best practices ensures that Perl scripts are reliable, maintainable, and collaborative. Modular code design involves breaking scripts into reusable functions or modules, which simplifies updates and testing. Comprehensive error handling, such as using eval or exception modules, helps scripts recover from unexpected issues. Documentation, including inline comments and external guides, is essential for team collaboration and future maintenance. These practices not only improve code quality, but also enhance the overall efficiency of system administration workflows. In summary, advanced Perl techniques empower system administrators to automate tasks, enhance security, and improve efficiency. By mastering modules like file, find, and IPK, Open3, and adhering to best practices, you can build robust tools for system management. Perl's flexibility and rich ecosystem make it an invaluable asset for sysadmins. As you continue exploring Perl, consider experimenting with its vast library of modules to address specific challenges in your environment. With practice, you'll unlock new possibilities for automating and securing your systems. Perl is a versatile programming language that has evolved significantly over the years. Perl 5 and Perl 6, now known as Raku, represent two distinct paths in the language's development. Perl 5 has been a staple for scripting and system administration, while Perl 6 was designed to modernize the language with improved features and usability. This presentation will explore the key differences between these versions, focusing on their syntax, performance, ecosystem, and practical use cases. Understanding these aspects will help you decide which version suits your project needs. Whether you're maintaining legacy code or building new applications, the syntax of Perl 5 is known for its flexibility. allowing developers to write concise code with minimal boilerplate. However, this flexibility can sometimes lead to cryptic expressions that are difficult to read or maintain. In contrast, Perl 6 introduces a cleaner and more consistent syntax, making the language more approachable for new and experienced programmers alike. For example, variable typing in Perl 5 is more implicit, requiring explicit declarations in some contexts, while Perl 6 offers more intuitive type handling. Method calls in Perl 5 often rely on a mix of symbols and functions, whereas Perl 6 uses a more uniform, object-oriented approach. Control structures in Perl 5 can be terse, but Perl 6 provides clearer and more expressive constructs, enhancing code readability and reducing errors. Perl 6 brings several significant feature enhancements that address limitations in Perl 5. One major improvement is built-in support for concurrency and asynchronous programming, allowing developers to handle multiple tasks simultaneously without complex workarounds. The regex engine in Perl 6 is also vastly improved, with grammars that enable more powerful and structured pattern matching. Object-oriented programming in Perl 6 is more robust, with better encapsulation and metaprogramming capabilities. Additionally, Perl 6 introduces modern data types like arrays, hashes, and sets with enhanced default behaviors, reducing the need for manual configuration. These features make Perl 6 a compelling choice for applications requiring advanced functionality and scalability. Performance is a critical consideration when choosing between Perl 5 and Perl 6. Perl 5 has been optimized over decades for legacy systems and scripts, making it highly efficient for traditional use cases. Its mature runtime and extensive libraries ensure reliable performance in environments where stability is paramount. Perl 6, on the other hand, was designed with modern hardware in mind, aiming to leverage newer processors and memory architectures. However, early versions of Perl 6 faced performance trade-offs, particularly in CPU-intensive tasks and memory usage. Benchmark comparisons show that Perl 5 often outperforms Perl 6 in certain scenarios, but Perl 6's design allows for potential improvements as the language matures. Understanding these trade-offs can help you select the right version for your specific requirements. The community and ecosystem surrounding Perl 5 and Perl 6 reflect their different stages of development. Perl 5 benefits from a vast existing code base and an extensive collection of modules available through CPAN, making it a reliable choice for projects that rely on established libraries. Perl 6, while newer, has a growing but smaller community with evolving tools and libraries that cater to modern programming practices. Adoption trends show that Perl 5 remains widely used in industries where legacy systems are prevalent, while Perl 6 attracts developers looking for innovation and advanced features. However, the smaller community for Perl 6 means fewer resources and potential challenges in finding support or experienced developers. Perl 6 is no longer considered a mere update to Perl 5, but a separate language with its own identity, now called Raku. This distinction allows Raku to evolve independently, incorporating modern programming paradigms without being constrained by Perl 5's legacy. Ongoing development focuses on enhancing performance, expanding the standard library, and improving tooling for developers. However, migrating from Perl 5 to Raku presents challenges, including compatibility issues and the need to adapt existing code bases. While efforts are underway to ease this transition, developers must carefully evaluate the benefits of Raku's features against the costs of migration. The future of Raku depends on continued community engagement and the success of its roadmap in addressing these challenges. In summary, Perl 5 remains the dominant choice for legacy systems, scripting, and environments where stability and existing resources are critical. Its extensive ecosystem and proven reliability make it a safe option for many projects. Perl 6, now Raku, offers modern features that can enhance productivity and code quality, but requires adaptation and a willingness to embrace new paradigms. When deciding between the two, consider factors such as project requirements, the availability of libraries, and long-term maintenance goals. Whether you choose Perl 5 for its maturity or Raku for its innovation, understanding their strengths and limitations will guide you toward the best solution for your needs. Legacy Perl code refers to programs that are no longer up to date, often lacking proper documentation or structured organization. This type of code can be challenging to maintain because it may rely on outdated practices or outdated libraries. Common characteristics include a lack of modularity, meaning functions and data are not separated into reusable components. You might find the use of deprecated features, such as older syntax or functions that have been replaced by more efficient alternatives. Inconsistent coding styles can make the code base difficult to read, as different parts of the program may follow different conventions. The challenges of working with such code include the absence of tests, which makes it risky to modify unclear dependencies that can lead to unexpected issues, and outdated modules that may no longer be supported or compatible with modern systems. To analyze a legacy Perl code base, you can use tools like Perl Critic, which checks for style and quality issues by enforcing best practices and coding standards. This helps identify potential problems such as inefficient code or security vulnerabilities. To identify outdated modules, you can use the cpanum command with the look option, which allows you to inspect the contents of a module before installing it, or the cpan command to check for available updates. Tracing dependencies is another critical step, and tools like module scan deps can help you understand which modules are required by a script or application. Alternatively, the cpanum command with the dep option can show the dependency tree, making it easier to manage and update the code base. One of the most common issues in legacy Perl code is the presence of hard-coded values and global variables, which can make the code inflexible and harder to modify. For example, a script might have a hard-coded file path or a variable that is accessed and altered throughout the program, leading to unintended side effects. Another major problem is the lack of error handling or exception management, which means that when something goes wrong, the program may crash or produce incorrect results without any clear indication of the issue. Inconsistent formatting, such as varying indentation, naming conventions, or the absence of comments, further complicates the readability of the code. These issues can create a significant barrier for developers trying to understand and maintain the code. Maintaining legacy Perl code requires a set of specialized tools to ensure clarity and reliability. Devel Cover is useful for analyzing test coverage, allowing you to see which parts of the code are tested and which are not, so you can focus your efforts on critical areas. Perl Tidy helps reformat code to follow consistent style guidelines, making it easier to read and understand. For particularly complex or obfuscated code, B. Deparse can be used to examine the parsed structure of the program, revealing how the code is interpreted by the Perl interpreter. These tools collectively help make the code base more manageable and reduce the risk of introducing errors during maintenance. Refactoring legacy Perl code should begin with small, incremental changes to minimize the risk of breaking existing functionality. Start by isolating functions into separate modules, which improves modularity and makes the code easier to test and reuse. Replace deprecated functions with modern equivalents, such as adding use strict and use warnings to enforce better coding practices and catch potential errors early. For example, replacing old string manipulation techniques with more robust methods can improve both performance and readability. By focusing on these steps, you can gradually modernize the code base while preserving its core functionality. Testing legacy Perl code is essential for ensuring that changes do not introduce new issues. Start by writing unit tests using test, more or test, simple, which provide a framework for verifying individual functions and modules. To compare outputs and detect subtle changes, test. Differences can be used to highlight discrepancies between expected and actual results. When dealing with external dependencies, such as databases or APIs, test. Mock object allows you to simulate these interactions, enabling you to test the code in isolation. These testing strategies help build confidence in the code base, making it safer to refactor and update. The key to maintaining legacy Perl code lies in prioritizing documentation and making incremental updates. Documenting code as you work on it ensures that future developers can understand and build upon your changes. Collaborating with team members through code reviews and knowledge sharing sessions can help distribute expertise and reduce the risk of relying on a single person. Finally, it is important to strike a balance between preserving the existing functionality of the code and modernizing it to meet current standards. By adopting these best practices, you can transform a difficult-to-maintain code base into a more robust and sustainable system. The Perl community is a cornerstone of the language's success and longevity. It provides a network of developers, experts, and enthusiasts who share knowledge, collaborate on projects, and support each other through challenges. Whether you are a beginner or an experienced programmer, the community offers invaluable guidance and resources. Key resources include platforms like Perl for local and global connections, CPAN for accessing thousands of modules, Perl for discussions, and IRC channels such as Perl for real-time interaction. Engaging with the Perl ecosystem involves participating in these platforms, contributing to open source projects, and attending meetups or conferences. By actively participating, you not only grow your skills, but also help sustain the vibrant Perl community. The importance of the Perl community cannot be overstated. Forums, mailing lists, and IRC channels serve as hubs where developers seek help, share ideas, and troubleshoot issues. These platforms foster a culture of collaboration where knowledge is freely exchanged and learning is a shared endeavor. For instance, mailing lists often feature in-depth discussions on best practices, while IRC channels provide immediate assistance for urgent problems. Mentorship opportunities abound, allowing newcomers to learn from seasoned professionals and experienced developers to refine their expertise. Networking within the community opens doors to career opportunities, partnerships, and a sense of belonging. By leveraging these resources, you can accelerate your growth and contribute to a collective effort that drives Perl forward. Several key communities form the backbone of the Perl ecosystem. Perl Mongers are local and global user groups that organize events, workshops, and networking opportunities. These groups are excellent for connecting with fellow developers in your area. CPAN, the Comprehensive Perl Archive Network, is a vast repository of modules that extend Perl's capabilities, making it easier to find and reuse code. Perl is a vibrant Q&A platform where users can ask questions, share solutions, and engage in discussions. Additionally, IRC channels like Perl on Freenode offer real-time communication, allowing developers to collaborate and solve problems instantly. Each of these communities plays a unique role in supporting Perl users, from learning to troubleshooting to contributing to the language itself. Online learning resources for Perl are extensive and cater to various learning styles. The official Perl documentation, PerlDoc, is a comprehensive reference that covers the language's syntax, functions, and modules. Perlorg and Perl Weekly provide curated articles, tutorials, and updates updates on the latest developments in the Perl world. Blogs such as Perl Blog and the Perl Foundation offer insights into best practices, case studies, and community news. Video tutorials on platforms like YouTube and Udemy are ideal for visual learners, offering step-by-step guides and real-world examples. These resources ensure that whether you prefer reading, watching, or interacting, there is a way to deepen your understanding of Perl. Tools and utilities are essential for efficient Perl development. CPAN and CPANM simplify module management, allowing you to install, update, and manage third-party modules with ease. The Perl debugger, activated with the command Perl D, enables you to step through code, inspect variables, and identify issues systematically. Perl Critic is a powerful tool for enforcing coding standards and improving code quality by analyzing your scripts for potential problems. Stack Overflow serves as a community-driven support platform where developers can ask questions, find solutions, and contribute their expertise. These tools collectively enhance productivity, ensure code reliability, and provide a safety net for troubleshooting. Contributing to Perl is a rewarding way to give back to the community and enhance your skills. Submitting patches to CPAN modules allows you to improve existing code, fix bugs, or add features, which benefits the entire ecosystem. Participating in Perl conferences like YAPC provides opportunities to present, learn, and network with other developers. Writing documentation or tutorials helps others understand complex concepts and contributes to the knowledge base. Reporting bugs and suggesting new features ensures that Perl continues to evolve and meet the needs of its users. Every contribution, no matter how small, plays a role in keeping the Perl community vibrant and forward-thinking. Staying updated with Perl's developments is crucial for maintaining relevance and proficiency. Following Perl news through Perl Weekly keeps you informed about the latest trends, articles, and announcements. Subscribing to Perl mailing lists allows you to engage in discussions and stay ahead of changes in the language. Joining online communities like Reddit's r/Perl provides a platform for sharing insights and learning from others. Attending virtual and in-person events, such as webinars or conferences, offers opportunities to connect with the community, gain new perspectives, and discover emerging tools and techniques. By consistently engaging with these resources, you ensure that your Perl skills remain current and adaptable. The Perl community is an invaluable resource for growth, collaboration, and innovation. By leveraging tools like CPAN and Perl Monks, you can streamline your workflow and access a wealth of knowledge. Active participation in the community not only enhances your skills, but also strengthens the network of developers who rely on each other. Whether through contributing code, sharing insights, or attending events, your involvement helps shape the future of Perl. As the language continues to evolve, staying engaged with its resources ensures that you remain at the forefront of its advancements, ready to tackle new challenges and opportunities. And just like that, our dreamy coding adventure has come to an end. I hope the gentle ebb and flow of the tutorial, combined with the tranquil melodies, have left you feeling both informed and at ease. Whether you managed to catch every line of code or drifted off into a peaceful slumber, remember that the world of Perl will always be here waiting for you. Keep your code clean, your mind open, and your spirit relaxed. Don't forget to subscribe to Code Snooze so you never miss out on another soothing coding journey. Hit that like button if this video brought you a moment of calm and learning, and share it with fellow coders or anyone in need of a serene study session. Thank you for joining me in this cozy corner of the internet. Until next time, may your code run smoothly and your dreams be filled with brilliant algorithms. Sweet dreams, sleepy coders.